2020 Limpopo Prelim Mathematics Paper 2 Memo. That is what we are going through today. So obviously, this PDF file is currently empty. I feel like that's a no-brainer. I'm like, duh, of course it is currently empty. But then in a short while, is that even correct? In a short while, well, in a short space of time, this will be all full and all that other stuff. So let us just dive into it. So obviously the one thing that you'll always hear me say is it's best for you to like try out these questions, and then once you have tried them out, or like once you have like gone through the paper and all that, you just want to then use the like the description as a way to like, you know, like in the description you'll see timestamps of like different questions and all that. But anyways, let me not waste your time and dive right into the whatever you want to call it. So with your paper 2, let's see, it says here 2 schools A and B in the Lipalale circuit are in competition. Oof. Yeah, I don't know what that is, but anyways, they're in a competition, né? And then they said here they want to see which one of them performed best in mathematics during June examinations. And then it says here both schools have 25 learners. Okay, fine. And then it says the 5-number summary of school A is this much. And then it says the box and whisker diagram for the learners in school B is this much. You see, so this the 5-number summary, we know that it refers to like the mean, the maximum, Q1, Q2, and Q number 3. So we can already see that, yeah, we're always going to compare this data at some point in time. It's like a no-brainer. But then here for 2 marks, it says here, draw the box and whisker diagram, which represents the marks of school, which represents the marks of school A on the grid in your answer book. Clearly indicate all relevant values. So, yeah, so here obviously what we need is some grid paper, and me, I got green grid paper somewhere in here, like I know for sure, in like my downloads. What? There's no grid paper in my downloads. What about my other downloads, eh? What about my other downloads? Gotta have some grid paper here somewhere. Oh well, can't find some grid paper. But anyways, this one, it doesn't look like we're going to have a hard time doing a box and whisker diagram for this. We can use this as a way to like help us, you see. So the first thing you want to do is, let's just draw a straight line here so that we can have like some form of scale, you see, because with your graphs, right, your box and whisker diagrams, you're going to have some kind of a scale, you see. So let me draw a straight line ISO. There we go, got ourselves a straight line. Now in terms of a scale here, I mean, like you could start with 10 here, and then you could just go in tens. So halfway here is like 50, 20, 30, 40, wait, 20, 30, 40, 20, 30, 40, 50, 60, 70, 80, 90. Oh, there you go. there you go. So we gotta move this thing as best as we can. So let's zoom out. There we go. But anyways, this is how you're going to draw your box and whisker diagram. All you need is a 5-number summary. So as long as you have the 5-number summary, you are good to go. So the minimum here is a 9, right? So obviously 9 is like just before 10. So you're going to draw a line just like that. And then this is like 23.5. That's your Q1. So 23.5 is like somewhere there. And then 55 is like in the middle. That's like your Q2. So let me just label these here. So you see here your mean, you have your Q1, you have your Q2. The minimum here we can see it's like 9. I mean like 23.5 over ISO. And then what you got here, this is like 55 over there. And then you have like 75. So that's like in between 80 and like 70. This, we know this is like clearly Q3. So let's put here 75. And then right at the end, which is the maximum, that's like 91, right? So let's put here 91 is just like right after 90. So let's do this. Box and whisker diagram is finally been drawn. There you go. So here, connect this, connect that. Here our maximum, we know it is 91. Voila. I'm like, oh my gosh. But for 2 marks only, this is kind of sad, you see. But anyways, I mean, you can't blame them for giving us 2 marks because they already give us the 5 number summary there. But at least 3 marks, yeah, Nacho. Like 2 marks only. Hey, it is what it is. It says here, determine which school performed better in the June examination and give reasons for your conclusion. Okay, this one is like a common question. Okay, so this being a common question, it's one of those questions where you need to kind of have an idea of like what to look out for from your question for you like to easily decide which one performed better. So likely here we can just compare like the 2 box and whisker diagrams. So the main things to compare is not the minimum and the maximum, because the minimum and the maximum, they are more like your outliers, you know. I mean, like usually the person that gets the lowest and the person that gets the highest, you don't want to look for, you don't use those to like determine how everyone performed, you see. What you usually can use to determine how good everyone performed is things like the median, and again things like the interquartile range and all that. So if you think of it, right, if you compare the two, the median here is like a 60, whereas the median here is like a 55. So I mean, like one way or the other, this is telling you that roughly speaking, B seems to have performed better. The reason why B seems to have performed better is because clearly you can see that this is telling you that half of the people, right, got more than 60. Because remember, this is the median. You see, this represents the median. This literally means that if you have these people stand in a line from like 1 to 25, all these 25 learners, if they were to stand in a line, the person that's in the middle got 60. The ones after this person that's in the middle, all of them got over 60, you see. But then here, this is telling you that the one that's in the middle got 55. So if the one in the middle here got 55, but the one in the middle there got 60, clearly these ones here where the middle is a 60 are the ones that performed better, you see. So here, for your answer, you can easily say B, right? And then you talk about the median. So B because 50% of, so 50%, or let's say because half of the learners, because it's the same thing actually, because half of the learners, oh my goodness, bro, why are you writing so fast? Just keep calm, man. Just keep calm, and like, you know, half of the learners, yes, what did half of the learners do? Half of the learners got more than 60 compared to those of class A, where half got above 55%. Above 55%. So this is basically to highlight that if you're going to compare marks, right, and you have 2 box and whisker diagrams, just use the median. It's a better indicator of like how people performed and all that. Anyways, learners at Bahananwa, yo, it has a dope name, man. Bahananwa. Learners at Bahananwa High School travel from 3 villages, A, B, and C. The table below shows the number of learners from each village and their mean traveling times from school to home. So mean traveling times refers to like the average traveling times. This is like, it's basically like saying an average. That's how long they like spend to travel and all that. So for example, here it says number of learners, you have like 110 35 learners from village A, 225 learners from village B, and this much from village C. So the mean average time, these are the average times here. Okay, for 4 marks. Oh my goodness. It says the mean traveling time for learners living in village C is the same as the mean traveling time for all 560 learners. Calculate the mean traveling time for learners in village C. So this one is quite an easy question, to be honest. But is it really? Oh damn. Let's read again. The mean traveling time for the learners living in village C is the same as the mean traveling time of all of them. Oh, okay. So the mean traveling time for all of them, right? This would this is interesting. So this is how here we need to be systematic. So this is basically saying 135 learners, right? On average, each of them took 24 minutes to like get to what you call. Is this going from school? Yeah, half of them. Let's see here. Learners from high school travel, yada 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 yada. And then so these are learners from high school traveling. So amongst these 135 learners, right? If the average is like 24, it means that the total of whatever it is that you would have been adding up in terms of adding up total traveling minutes, right? The total traveling minutes is 24 minutes times 135 learners. So let's say here total time. So this is the total time, right, for the learners in village A. For the ones in village B, the total time that they spent going to school is about 225 learners, right? Each of them taking about 32 minutes to get to school. So their total time here, we'll just get that from the calculator, because this is not the NBT, so we can definitely get the calculator. Let's see there. So the next one is obviously just going to be 200 times x. So 200 times x, this represents everyone. I hope I gave myself enough space. I didn't. Oh my goodness, man. Oh man, this sucks so bad. Like, oh man, huh? I always just wonder, like, what's the point of giving yourself so little space when you know you write like you're writing with your left toe or whatever? But anyways, it is what it is. So this here, let's see what this gives us in our calculator. So the total time for the guys in village A is like 135 times 24. That is 3,000. How? 3,000 and what, man? 3,000 and what? Give us the answer, man. Give us the answer. Hi, but let's just get the answer in the calculator. It's like 3,240. So this is like 3,240. Or let me just do all this at the same time, really, because this is honestly speaking just like wasting time. Like, to be honest, this is just like wasting time. And excuse me if you had like written out stuff. I'm sorry. So we're just going to take this total, right? And then we're going to add it to like this total. And then we're just going to add it to like this total, you see? The reason we're going to add them up is because this is going to give you like the total number of minutes that everyone spent going to school. So these total number of minutes that people spent going to school, right? You're going to divide it by the total number of learners. So the total number of learners, they told us it is 560 learners in total, you see, because like this and that. So this is obviously the average, right? So they said this average here is the same as the average of the learners from village C. So this figure here is the same as the average of the learners in village C, of which the average of the learners in village C, it is just x. And then from here we can just solve for x. So solving for x, we know we can multiply by 560 on both sides. You're gonna have 560 on the left, obviously. This you may want to just put in your calculator, like these two brackets here. Let's see what they give us. So those two brackets in particular, the first one is going to give you 3,240, and then the other one is like 7,200. So it's like 3,240 plus 7,200, and then this is just obviously like 200x. This is equal to 560x. Yes, there we go. And then solving for x here, I mean, like, it's really no big deal here. Like, come on now. We can take the 200 to the other side. We're gonna get 360 because, I mean, like, it's just, quick math. And then on the left, we're going to have 10,440 actually. And then if you divide by x on both sides, your final answer, it is just going to give us 29. Like, oh my goodness, this is so fantastic. Okay, nothing crazy here, nothing major. They didn't ask for anything much really. They just said we should calculate the mean traveling time for the learners in village C, of which x is what's in village C. So we can move on to question number 2. Question number 2 in this 2020 Limpopo prelims mathematics paper 2 memo. Let's see what question 2 wants us to do. It says here, learners who scored a mark below 50% in a mathematics test, okay, were selected to use a remedial program to improve their marks, okay. On completing the program, these learners wrote a second test to determine the effectiveness of the intervention strategy. Ooh, okay. The mark scored by 10 of these learners in both tests is given in the table below. Okay, fine. So they're taking learners, right, that got below 50. And then these guys were said that they were made to write tests. Okay, they said here they were selected to use a remedial program to improve their marks on completing the program. So this is after they've taken the program, right? Those learners wrote a second test to determine the effectiveness of the intervention. The mark scored by 10 of these learners in both tests is given in the table below. So you see that what they mean is this is the test before the intervention. So let's say here before the intervention, and then this is the mark after the intervention. You see, intervention after. So the big idea here is, obviously with questions like these, I mean, it's statistics. You're obviously going to eventually like compare the data and all that. For 3 marks, it says calculate the equation of the least squares regression line. So getting the equation of the least squares regression line, it is not a hassle at all. It's clearly just like calculator work. So the first thing you want to do is, in your calculator, you're gonna put the you're going to write out this on your paper. However, in your calculator, you're going to press the following. You see, you need to press mode first. You see, you need to press mode and then stat. So in your calculator, let me do here calculator. You are going to press the following. You're going to press mode and then stat, and then there's an option that has a plus b in it with x there. So that option is going to allow you to like put in data in your calculator, you see. So you can just put the first, this is going to be x, this is going to be like f of x. It doesn't matter. The ones at the top, you can just make that x, you see. The ones at the bottom, you can just make that f of x. Now the idea is, obviously you want to sub in all this data, the one at the top in this one column here, and then you want to just sub in this here into your second column. So you're gonna sub in all this value, right? You're gonna sub in, and then the moment you're done subbing in, right, you can now use your data, like the values that you would have like thrown into your calculator. So after this, right, you're going to press the AC button, and then for you to access the equation, the least squares regression line, you just need A and B. So you're going to click the AC button. After that, you're going to press shift. How did I give myself so little space? Like, to be honest, you're gonna press shift mode. No, you're gonna press shift and then the button 1. You see, shift and then the 1 button, and then you're going to go to stat, and then from stat you're going to go to there's an option that says reg. Yep. Going to say shift stat and then 1. And then there's an option that says like reg. So after choosing the option that says reg, you're going to choose A, and then later on you're going to choose B. You see. So after choosing A and B, let me just do that. In your calculator, from your calculator, you're going to get y is equal to 23.19 plus 0.77x. So this is what you're going to get for A. This is what you're going to get for B. See, these are the steps to get those values, you see. So yeah, shift mode stat, you're going to go here. So from here, let me just show that this is like where you go next, you see. Fantastic. The next one says the total of test 1 is 50. The learner's mark for test 1 is 15. What? Good lord. Oops. The total for test 1 is 50. The learner's mark for test 1 is 15, which is 30%. No. Oh yeah. Duh. If it's out of 50 and the person got if it's out of 50 and the person gets 15, it's relatively 30%, because I mean, like this mark, right? I mean, like 15 out of 50, if you're going to times it by 100, you're going to get 30%, you see. That's that. So here it says predict his mark in percentage for test 2. Give your answer to the nearest integer. So questions like these, they basically just require you to like use your equation, you see, because your equation is like used to make estimates based on like information that you will have and all that. So here we can put there, let's see, wherever x is, that goes, that's what you put there for test 1. So these are percentages, right? So obviously when you're throwing stuff in here, you want to put a percentage as well, not like 30%. You're just going to drop in the number 30 where x is. So here, let's see, we're gonna have y is equal to 23.19 plus 0.77. If you drop a 30 here and then you just double check this in your calculator, that's what this gives us in the calculator. In the calculator, this is giving us a whopping 46.29%. And then obviously if you're going to round this off, I mean, like based on these figures, all these figures are rounded off, so this is going to be 46%. Nice. Nothing major, nothing crazy. Let's just keep moving along because we've got other questions to do. It says for the 10 learners above, right, the mean mark for the second test is 49.4 and the standard deviation is like 10.99. So obviously from the statistics course, it is made clear that your standard deviation gives you an idea of how far on average each value is from the mean. You see, that's what standard deviation is, and this is something that is worded out in the course platform, like on the statistics course. Standard deviation is how far on average, let me make sure that this word is like clear, how far on average each number is away from the mean. So basically what they do with standard deviation is they take the mean, right? You take the mean and then you work out the distance between the mean and every single number on the right of the mean and every single number that's on the left of the mean. You see, you take all those distances between those numbers, you add them up, and then you divide them by how many numbers you're dealing with. That will always give you your standard deviation. You see, because remember, your standard deviation, as we said, tells you how far on average each number is away from the mean. Okay, so that is like all nice and dandy. So let me just remove this thing here. Do this. There we go. There we go. Nice. So, wait, are we even done? We haven't even read the question. It says, what is the standard deviation after... Whoa, bro, we didn't read the question fully, man. We're just getting carried away with explaining what standard deviation is. But anyways, it says here now, the teacher discovered that he forgot to add... he forgot to add the marks of the last question to the total mark of each of the learners, right? And then it says all the learners scored full marks in the last test. So meaning everyone's mark for the last test was exactly 100%. And then it says here, when the marks for the last question were added, the new mean mark is like 57.4. Then it says, what is the standard deviation after the marks of the last question were added to each learner's mark? So, I mean, the funny thing is, if everyone's mark changes the exact same way, it basically means that the distance that they are away from the mean, or the average distance that they are away from the mean, it's not necessarily affected. It's going to stay exactly the same, you see. So that's why the total standard deviation here, it's still just going to stay 10.99. The reason why it's going to stay 10.99 is because every single value has increased by the exact same value, you see. So everyone is still spaced out the exact same way. It's just like if you add $200 to like $100, and if you add $200 to $500, the distance between those two figures, it's still exactly the same. You see, I feel like what I said right now is like, wait, what? Dollars? Why are you talking about dollars and adding stuff? Well, what I'm trying to say is, if you have 2, right, plus 5, and you have 6 plus 5, you see, if you add 5 to this number, that's going to give you a 7. If you add 5 to this number, that's going to give you an 11, you see. So initially, I mean, like, if you think of it, the distance between 2 and 6, it's just 4, you see. And then if you add the same number, I mean, the distance between 7 and 11, it's still just 4, you see. So that's why the standard deviation does not change, because you've added everything by the exact same value anyways, you see. That's why the standard deviation does not change. So let me just erase this just so that it doesn't seem confusing, unlike the PDF file. And obviously the PDF file, I mean, like, you can just download that from the description. It says here, what is the total mark out of 50 for the last question? Ooh, okay, so if the average changed, that's what we need to focus on, because if the average changed, that's what we need to focus on. It says here, 10 learners, for the 10 learners above, the mean mark for the second test is this much, ne? And then it says here, when they added the last question, they had a new average now, you see. So how many marks is this question that they're asking us to work out? So this question that they're asking us to work out, it is clearly just a 2-mark question. So the one thing that you want to do with this question is, you want to take your new average, right? So you want to firstly check the difference between the averages. This is like 57.4. Well, it is a percentage, so you can just work with percentages for as long as you can. So here, if you don't work with percentages, I think it's relatively okay, to be honest. Like, let's see here, this number, right, minus the first percentage. Let's check the percentage difference first. So the percentage difference here, if you check in your calculator, this is like exactly 8%. You see, so there's an 8% gap. So the idea is, if there's an 8% difference, right? So here it says 8% difference. You see, 8% difference. You see. So obviously, if we're going to see the total mark for the last question, the total question, it contributed to like 8%. So 8% of 50 is basically what we want here. 8% of 50 marks. This is what the last question was, you see. Of which 8% of 50 marks, we know that it is just the same as, like, in your calculator, I mean, like, you're just going to put this, and then it's going to give you a 4, because 8% of 50 is just 8% times 50, and then this figure here is just a 4. And then we're just cruising along very nicely, 2 questions down the line. So let's move on Question number 3. We are dealing with question number 3, like. That is good. It says here now, in the diagram, the straight line SP is shown. Okay, so whenever you're going to read something that is a diagram, I'm like, you don't want to just read without even seeing what diagram they're talking about and everything. What if they're lying to you? Well, they'll never be, but I mean, let's pretend. It says here, in the diagram, the straight line SP. So you obviously have SP here. It is a straight line. Okay, frontal. Hey, what is this now? We can see it starts from S, it goes to P. Fine, it's SP. They said it is drawn with S and P as X and the Y intercept. So it's the x-axis here, which is S, and then the Y intercept there, which is a P. And then it says here, the equation SP has this, the line SP has this equation. So obviously there's like an equation of a straight line, but it's not like in the standard form that we are used to. Then they just said here x is bigger than 0, and then they said if, and then said it is given that SO, where is SO? SO is equal to 3 of OP. So SO is 3 times OP. So there's SO. Where is SO? Yeah, see, man. No. Well, if you see that they're talking about SO and there's no O anyway, it means that they're talking about the origin. So they said here SO is equal to 3 times whatever OP is. It kind of makes sense. So normally when you see stuff like this, you always want to write one variable in terms of the other. You see, meaning here you already know that this is like OP. Perfect. And this, you obviously want to remember that this is just going to be 3 times OP. So let's put here 3 times whatever OP is. Okay, fine. All this being said, they said here the straight line TR is perpendicular to like PS. TR, where is TR now? TR is perpendicular to PS. And then it says here TR cuts the y-axis at T. Where is T now? Okay, fine. That's all good. That's all fine. For the first 3 marks, they say we should get the coordinates of P. Ooh, getting the coordinates of P looks like it's going to be quite easy, because I'm like, we have SP. And let's just, it looks as though we're going to use, what are you going to use? Well, it's a 3-mark question, so we're obviously not going to panic. As long as we find the y-intercept of this line here, we're good. But let's just do it. Let's just take this equation here without overthinking it, as you should not. Here, I mean, like, they've given us the equation of the graph we are talking about. So if you say that you're given an equation of whatever graph you're talking about, I mean, just use it, just use it. Yeah, you're better off using that graph, even if it's not complete and everything, than if you just like, stall and you're just playing around, not doing anything. It does not work. So let's see here. What am I trying to do? I'm trying to copy this thing here. Let me copy it. And then this equation, we said our initial task should be to just put what is this? What should we do again? We should put y as the subject of the formula, because y is the subject of the formula. It opens your mind. So here it looks like we can take out a as a common factor. Let me do here x. Seems like nothing is wrong with x. Let's do here x plus a goes out, right? This is like y minus 1 equal to 0. And then obviously, well, we want to make y the subject of the formula. Yeah, this is quite tricky. Okay, it's not actually. Making y the subject of the formula, y can just stay on its own here, right? And then the rest can like just go to the other side. Let me see here. This is going to be like y is equal to what? Y is equal to like positive a minus x. But we want to write the x first, because we want to be able to see this in its standard form. Negative x is going to be there, positive a. So obviously, oops, excuse me, I didn't write the a in front of y. But then obviously both of these, or the left and the right, you're going to just divide by y, right? Yeah, you're going to divide by a, sorry. So it's like a with divided by y, a divided by a, and then here this is going to divide by a, And then look, we're going to see our y-intercept because we're dividing by a. This is going to cancel each other out. You're going to have therefore y is going to be equal to negative a, because you see there's a negative 1 in front there over this denominator. The x, you can just write it next to it like this. It is 100% legal, and this is in standard form, you see. So clearly what they had given us, it looked like they'd not given us enough information, but they had given us enough information clearly, because this is clearly just y is equal to mx plus c. Oh, voila. Like, yeah. It's all good. It's all good. Let's just do what we can. So, yeah. Let's just move on to question number 3. Question number 3. Where is question number 3? No, we are at question number 3, bro. They say we should calculate the value of a. Oh, we're not even done with this question. I'm busy moving on. Like, bro, what are you doing now? The reason I wanted the y-intercept is because if you know what this value is, this is just the 1. Because of this here, it's just the 1. So it means that the coordinates of p, the y value is just the 1, the x value is clearly just a 0. And that's it, you see, because it's like on the x-axis, I mean, it's on the y-axis, and then it's like 1 unit upwards. So, yay! Getting the value of a, I mean, like, for 3 marks, I would most definitely start off with the equation that we have just worked out. I mean, like, this equation, it was not free, you know, so gotta use it. Now, in terms of you getting a coordinate that this graph passes through, I mean, you obviously can't use p, you know, because p is just your y intercept. So if you're going to throw your x value here as 0, obviously, I mean, like, everything gets cancelled out, so you can't do that. So we need to think creatively in terms of getting this value of a. Clearly, getting the value of a, we can do it as long as we get the gradient, you see. Now, I'm thinking to myself, wait, why did I get so excited? Oh, wait, we can actually just think outside the box. This is like 1 unit net, so it means that this is like 3 units, because remember they say this is 3 times the other one. So, I mean, if we had the length of PR, our question is, does that help us with the distance? I mean, does that help us with the what you call? With, what is the question even asking? To get the value of a. So me thinking of getting the value of a, yeah, definitely the one thing that comes to mind is like working with things like the gradient, and yeah, you know, just the simple stuff, because I genuinely would not want to overthink a question, even especially after we would have like had whatever it is that we would have had and stuff. But let's see here. This is good because we've just gotten coordinate s now. Because if this is like 3 units net, this is just 3 coordinate 0. Now this is a proper you know, value to like throw into the graph. The reason why obviously this is just 3 coordinate 0 is because, I mean, this is 3 times that one, you see, and because we want the gradient of this line here, or rather the equation, we can easily think to ourselves, let's get the equation of this line. So getting the equation of this line, we have the y-intercept. Now we just need to throw in a value that the graph passes through, you see. So this is going to be like y minus y1 is equal to m. M in this case is the negative 1 over a. And then let's see here. So this is just like let's see, this is like y, right? Y1 is the coordinate. The y value of the coordinate is like a 0. The x value is like a 3. So y value is a 0. And then gradient is like negative 1 over 5. So it's like negative 1 over 5. And then here we have our, what you got? You got like a negative 3 over there. Let's just simplify. See what you get. Wait, what am I getting here? I feel like, oh no, this is actually not necessary, because this is when you want to get the full equation. Like, oopsie. We can actually just throw in the coordinate here, where x is and where y is. Because what I was doing right now, it doesn't look like it was going to give us what we want. So here where y is, we're going to put a 0. Where a is, we're going to put a 3. And then here, let's see, you're going to have like negative 3a, negative 3 over a, plus 1 equal to 0, right? And then this, because it's a negative, you might as well move it to the other side. So that becomes a plus. And then I'm thinking to myself, I'm trying to get a, and I'm busy here. A is at the bottom. So here it looks like you can just multiply by a on both sides. The fortunate thing is you're multiplying by 1 on the other side. So A here is just going to come out as a number 3. Number 3. Yeah, 3 for number 3. Which is good. Which is real good. Because that is just how we like it. So let's move on to the next question. It's also out of 3. They said here we should determine the equation of RT in terms of what? In the form y is equal to mx plus c. So we're purely getting the equation of a straight line here, of which I mean, like, if you have come this far in this thing called mathematics and school, then you know that anytime you need to get the equation of a straight line, it's like a party, you know. So let's get RT here quickly. Getting RT, I'm like, looks like it's going to be quite simple because we have the gradient of PS already. So we can just use that, you know, as in we do our calculation using M1 times M2 is equal to -1. So here, I mean, to get the gradient, right, we know that we can just get the gradient of like, but we don't have point R, do we? No. Oh, well. I guess no, we can just use the gradient formula, bro. Like, it's just so in our face. You know, this Y value is a 1, but then the X value is also is like a 0. So this is 0 coordinate 1, nothing too extravagant ISO. And then what you got now? What is else? What is else? Ooh, it's quite creative. So the gradient, so the formula for your gradient, we know that it's just like y2, y1, yada yada, all that stuff. So we know that here we can just say, if you check on your formula sheet, y2, in terms of like you labeling this, it doesn't matter how you label it, you see, as long as you can like understand it and like remember it and everything, you see, you won't get penalized for like not labeling it or whatever. But as long as they match, like here you see x1 and like y1, and then here you just have like x2 and like y2. So it's gonna be like 1 minus 0 and then 0 minus 3. So let's see here, 1 minus 0, no, did I just say 1 minus 0? Yes, I did. And then 0 minus 3. Come on, bro, you just did. 0 minus 3. So here this is going to give you a negative gradient, but I don't even know why I even had to do all that, because I mean, like, we just got this gradient here. We got A as 3, so it's already a negative gradient. Like me, I feel like I'm just like taking the long tries here. Just long tries all the way. But anyways, this is the gradient of like PS, you see. So it's not like what we want actually, but it is there to help us get what we want. You see? So here we know that the gradient of PS, if you multiply it with the gradient of what's this gradient now? Where is it? Come on, man. The gradient of TR, if you multiply those two, right, they should give you what you want. So it's like M here, this is like TR, this is like -1/3. So I mean, there's nothing crazy here, nothing major. We just need to put in our values. Like here, this one we know it's like -1/3, and then whatever this is, it's just like M TR over there. This is good, like -1, bro. Why did I just write -1/3 here? I feel like my brain is like being toasted and being fried way too early, you know, way too early. But anyways, this is equal to like -1. So yammer, -1. And then obviously on both sides you do want to just divide by the same value. It is not gonna be an issue. Let us divide by -1/3, -1/3. So this cancels that. The minimum of like TR, this is like this divided by this in your calculator, it's gonna come out as a +3. So now you obviously have what you call a gradient for TR. That's like the bulk of the work. I mean, like, now you can just use this coordinate to give you the y-intercept, you see, because I'm like, look, the graph is touching the y-intercept over there, and us knowing that that is the y-intercept, I mean, like, we can just double check the description, you see, because like the description would mention some of these things. You see, it says a TR cuts the y-axis at this point. So this is your y-intercept. This as a fraction or as an improper fraction, it's just like -5 plus times the Well, what am I doing? What am I doing? Like, for real though. It's like 5 times 3 is like 15. And 15 plus 2, that's like 17 over 3 with a negative. So that's the y. Yes, it's negative 17 over 3. So it's like y is equal to 3x minus what? Minus? Why didn't I just say plus or something? Wait, I lost my image. Where's my image? Well, did I just lose what I was looking for? Oh, wow. But I remember it was like 17 something. 17 over 3. Yep, it was. Yep, it was. Yep, it was. But anyways, this is all worth that question. Nothing crazy. Now, obviously, we just need to do what it is that we can. When you look at that, they want us to get the coordinates of R. So in order for us to get the coordinates of R, this one is like, quite simple, because R is the point of intersection of like SP, or like, yeah, SP and TR. So we legit just got the equation of like line TR, right, which is this one. Perfecto. And then we also have a value for A, so technically we also have the equation of wait, what no ways, wait, we have SP, and wait, we just got the equation of TR. Yeah, you see, we have A from like our previous question here. You see, that technically gives us the equation of like SP. And then here we just worked out the equation of like TR. You see here we worked out the equation of like TR, which is this one. So we know they meet at R specifically. So R is like the point of intersection for those two equations. So this equation, wherever A is, we can throw a 3 over there. So obviously, technically, you can just take this whole thing here. Let us copy it. On your side, you're probably going to have to write it down. So, oopsie. Anyways, let's see. So that was the equation of what? Was it ST? Yeah, it was SP. So with SP, right, this is the idea, you see. The equation that we have, we know that wherever A is, we can just drop a 3 over there. So let's remove this, remove that. Drop a 3 over here, drop a 3 over here. So if we're going to equate our equations and work them out simultaneously, we may want to put this in like standard form. And we know we don't know what this is going to look like. I feel like I don't even know why I'm doing all this, because like, to be honest, it is necessary. Oops. Anyway, that's fine. Making y the subject of the formula here, we know that the 3 is going to go over. It's going to be a positive 3. And then here you're going to have 3y. Wait, actually 2 things are going to go over. But oh, come on now. You're going to have 3y left. And then this is going to go over. It's going to be a plus. Let's actually write the x first, because like, it's just a bit more natural. Plus 3 over there. And then we can divide both sides by a positive 3 there. And then plus 1 over here, you see, because they're dividing by 3 on both sides. So these are both equal to y, so you can just equate the 2 equations now, because you're trying to get R, which is the point of intersection between these 2 lines. So this here, we know that it is equal to, oh, what's going on? No. Yeah, this thing here, it is equal to like 3x minus 17 over 3. So the idea is, with this kind of equation, I mean, like, we can already see that, well, you don't have to do exactly what I'm going to do now, but I'm going to take the ones with 3 as the denominator on one side, so that I can put 3 as one denominator. And then everything else, let's just throw it over to this side. Negative 17 over... No. The negative 17 is gone. So here it's going to be like a positive 3x. And then let's just minus a 1 here. So the reason for doing this is so that we can just have negative x plus 17 over 3. Here I'm just trying to just simplify, you see. So here, obviously, there's no issues. There are no issues, maybe. It is what it is. And then here, let me just cross multiply, because why not? We're doing this because it's just a way of simplifying. If you wanted to take this over and say 3 plus 1/3 or whatever, it's okay. So here, cross multiplying, it's this times the 1. Do an arrow, make an arrow over there. So 1 times that top part, we're cross multiplying here. Still just going to give us the same thing. 3 times this bracket. Remember, this is together. So here 3 times this bracket, you're going to have 9x and then minus 3. This can go over, it's going to become a 10x. This can go to the other side, it's going to become a 20. And then obviously divided by 10 on both sides, x is going to be a whopping 2. Like, how satisfying is that? You know, how satisfying is that? Because obviously when you get full numbers as like answers, it feels good. You know, it feels so good. But anyways, we have got x as positive 2 here. So to get the y, we can just throw into any of these equations. So let's see here. Y is equal to negative 2 over 3 plus 1. This is going to give you a positive a third, you know, because that is mathematics. That is how it works. So here we can say, therefore, r, the x value we found it to be a 2. The y value we found it to be like a half. That is great. That question wasn't so bad, to be honest. Here they want the area of PRT. Where is PRT? PRT, where are you? P, R, and T. Okay, this one is quite easy because this is a right angle triangle. We have the coordinate of R now, which is just what side? What are you here? 2 and a third, you see? So you can get the distance of RP, and then you can just get the distance of like RT, and then just use your normal half base times height formula, you know, like it really isn't an issue. So let's see here. This is going to seem a bit strange, you know, but I am going to show you a trick. Am I going to show you a trick? Am I going to show you a trick? I'm like, why are we working with tricks and not just like, you know, proven methods here? Why are we not working with proven methods? Well, I'm like, it's okay to work with proven methods, yes, but if you have a shortcut, use it, you know. So yeah, let's see here. This one is quite an interesting question. I mean, like, to just make your life easier, ne? Don't worry about doing anything fancy. If you see that what you are going to do is immediately going to give you the answer, like even you getting the distance here and you getting the distance there, if you know that that is definitely going to give you the answer, then go for it. Let me just double check here that I'm working with the correct triangle. PRT. Let's see here. PRT. So we could say half base times height. I'm like, most definitely, right? Half base times height. So let's see here. Half base times the height. Half base times the height. Half base times the height. Half base. Wait, where is x? X is like 2 there. Oh, wow. So I'm going to do something that you might not like, but I'm doing it because I want to show you a different method of getting the area. Instead of getting the distance here, getting the distance here is what you'd normally have done, and then getting the distance there. This is what you'd have normally done, but let me show you something else. You see that this triangle here, if you're looking at it like this, right, even though there's a 90-degree angle there, it doesn't matter. If you're going to be creative, right, you know that PT can be looked as, you can see that as the base. You see PT, you can see it as the base. Let me actually copy this here. No, wait, let me not. Can I? Yeah, you see this here. Let's maybe copy it over there. Let's paste it down here. I hope I can rotate this thing. Like, I really hope. If I can't, then this thing is like so dumb. Like, why? Please rotate or something, you know? Like, really, bro? You can't do some rotating things. This thing is dumb. But anyways, I'm gonna do it on my own then. So if you look at what we have here, you have to be careful here, because it's actually quite simple to get this triangle here, or the area of that triangle. Because that triangle, right, looking at it in another light, you have like this point. This is like R up here. And then here you have like P. And then on this side here you have like T, right? And then it looks like this. Whoa. It looks like this, you see. Don't be fooled by the fact that this is a 90-degree angle. It's okay, you know. Getting this distance and getting this distance and then doing half base times height like that is 100% fine. But another way I want to show you is, if you know that with a triangle, as long as you have this point here, if you draw it going straight towards any side, as long as it's perpendicular to that side, you can look at this as the base here, and then here you can look at this as the height. So in our case, we already know that the distance from R going straight to TP, this distance here is a 2, because the x value of R is a 2 over there. And then we know from P going to T, it's just a matter of comparing the y values. Like here, we know that this distance here is like 5 and 2 over 3. This distance over there is like 1, you see. So PT is technically this number plus 1 over there, you see. So here our height, we know that this is equal to 2. Our base, we know that this is equal to 1 plus 5, 2 over 3. And you may be asking, but then this is a negative going down here. Yeah, it's going down. It's a negative, yes. As a coordinate, this is a negative. But if you're looking at it as distance, the distance here is like 5 and 2 over 3. So 5 and 2 over 3 plus 1 is just going to give you 6 and 2 over 3, you see. 6 and 2 over 3. Now, be careful. When you use your calculator and you want to put mixed numbers, always write shift first. Always go shift. Always press the shift button and then press the fraction button. You're going to get this mixed fraction here, you see. You're going to get a mixed. That's how you use a mixed fraction in your calculator. You see, don't say fraction and then put the 6 in front of it manually. You see, that won't work. You will always cry if you do stuff like that. So here the area, now we can say therefore area. Whoa, bro. Whoa. So therefore the area here is going to be a half. The base is going to be 6 and 2 over 3, and then the perpendicular height is just a 2. So all this, obviously, if you throw it into your calculator, I mean, like, you're just going to get 20 over 3. And then, I mean, like, we don't know what we're dealing with, so you can just say square meters, square units. You see, let me actually write the whole thing, because why not? The boy's feeling funky today. Square units. The lucky thing is this is not physics, so if you don't put units, it's not something that you're necessarily going to be like penalized for, you see. So, but obviously if you know the unit, just throw it in there, show that you're woke. Question 3.6. Calculate, giving reasons, the radius of a circle passing through the points PRT. So let's see where PRT is. PRT is this circle here, PRT. They want us to get the radius of the circle passing through that, and they say we should give a reason. Well, it's just a 2-mark question. The reason it's a 2-mark question is because they know that we should have our basic theory will tell us something specific about a circle that passes through PRT here, because look, there's P over here, R over there, there's T here, T down there. Well, bro, there's T down here. Come on, put T. The big issue is this is a 90-degree angle. So if you think of the law of circles, right, that says an angle subtended by the diameter of a circle is 90 degrees. If you have a circle that goes like this circle is not going to look very nice. Oh, it actually is, eh? Oh, damn, okay. Let's go, yeah. Ooh, look at this circle. Oops, that sounds weird. Like legit though, like bro, what the hell? Well, okay, it's not very circle-ish, but it's a circle. You see this circle here, you can already see that the center of the circle would be in the middle of like P and T, like, no cap. Yeah, of course. I'm like, it's really right in the middle, because there's no ways that your center can be anywhere except for in the middle of this, because you see a line subtended by the diameter of a circle is equal to 90. So this has to be the diameter. So this and that's the radius. This is the radius. So the distance of TP, we know that TP, wow, why is it so thin now? Why am I zoomed out? It's just the purple. So here TP, we know it is equal to 6 and 2 over 3. So we know that radius is half of that, you see. Radius is equal to half multiplied by this value, you see. If you multiply your half by this number here, you're going to get, what am I getting there? 10 over 3, you see, 10 over 3. So the big issue here is that, remember, in your calculator, press shift first before you press the fraction button for you to be able to press shift and then a fraction button in your calculator for you to be able to put in 6 and 2 over 3 properly, you see. So that is all good and that is all nice and dandy. Question number 4, we are moving along just fine here. It says in the diagram, the circle with this equation with center C. This looks like a nice doable question. I'm like, look at it. Look at it. It looks so harmless. It says here, this circle with this equation, right? This is clearly not in standard form. So putting it in standard form by completing the square will give us the center of the circle, which is C. It says here it cuts the y-axis at A. Okay. And then it says BA, British Airways, is a tangent to the circle at B. And then it says here B lies on the axis. Yes. No, B lies on the x-axis. And then it says BAY is equal to alpha. This angle here is equal to alpha. Okay, that's fine. That's fine. It's okay. We're probably going to have to work that out at some point. But for 4 marks here, they said we should determine the coordinates of length and the coordinates of C and the length of the radius. It is quite simple because they clearly just want us to put this circle into standard form. I mean, like, this question legit just screams put the equation of this circle, or rather put the equation of the circle into standard form. That's literally all they want us to do here. We're not even going to argue with them. It's not even a big issue. It's 100% what they want you to do. Don't overthink it. So getting the equation of a circle into standard form, that's something that's covered in like the analytical geometry playlist. But anyways, let's copy this question here. So it says x squared. You know, why I gotta use such a thingy here? So putting the equation of a circle into standard form, it's really not something difficult. You see, this is something that you need to walk into your exam knowing how to do it, you know, because if you don't know how to do it, yeah, you're going to cry. Okay, you're going to cry so hard, and crying so hard is not good. So let us do it. For 4 marks here, it says, yeah, let's get this equation to standard form so that we can work out what we need to work out. So putting an equation of a circle into standard form, you want to look at this portion of your, this here, what goes together, this here goes together. So the first thing you're going to do is this thing here, right? You're going to find, this is, we call this the B value for this expression. So for this scenario here, you're going to add negative 6 over 2 squared. And then for this one here, you are also going to, because you have like negative 4y over there, for this one you're going to add negative 4 over 2 squared. So these two numbers that you've added on the left side here, you're going to add them on the right as well. So here you're going to put plus negative 6 over 2 squared and then plus negative 4 over 2 squared. So this, doing this has the same effect as like plussing this and then minusing it, plussing this and then minusing it. So because you're not like minusing it on the left, you can just make sure you add it on the right side, because obviously if you had minused this, if you had said this, if you had plussed this here, right, and then you minus it, and then if you had plussed this here and then you minus it, eventually what you'd have minused and what you'd have minused, you'd need to like take them to the other side, which would just look like this. But anyways, carrying on, the next step here is quite simple, because the next step literally just says this is a trinomial, this is a trinomial. Inside here, you know, you have like negative 3. So you're going to take x with this negative 3 here. You're going to put it in brackets squared. That literally replaces this whole thing. You do the same for this y. You're going to say this y, you put it in brackets with this value. This is like a negative 2 inside here. And then that whole thing replaces your 3 terms. You see, you'd have factorized. And then on the other side, feel free to throw everything into your calculator, because that's exactly all you got to do, you know. All you got to do is throw everything into your calculator. If you throw everything into your calculator, you're getting a 25 here. So obviously if you're going to put everything in standard form, this is like your r squared. You see, r squared is equal to 25 because this is already in standard form of a circle. So here r is equal to F5 maybe. So here, therefore, we need to make sure that we show them what C is. C is the X value is the opposite of 3. And then the Y value is like the opposite of 2 because of the theory that we know. So obviously, if the basics and the theory is something that's difficult for you, I recommend you enroll yourself onto the course platform, like legit. Save yourself. 8-mark question. What? I haven't seen an 8-mark question in like forever. Wow, man. They want us to get the equation of what? Of BA. Yeah, these guys are crazy, eh? Well, obviously, if you're gonna get the equation of BA, just remember that BA is it's a straight line, you see. It's just a straight line, so do not panic, you know. Panicking is really not a good idea. So with BA, you really have to think outside the box, like legit, you see. Because with BA, the issue is you have B here and you have A over there. So the sad thing is the description absolutely has nothing but the equation of your circle given. So you may want to use the equation of your circle to help you here, because in the equation of your circle, A is 0, and then the X value is 0, but the Y value you actually don't know it. So let's leave it out. What else do we know? Tricky. So what I can do first is, we can start by getting an expression for A. To do that, we can just take the equation of our circle and then throw 0 where X is. So our equation of our circle, right, if you paste it here, the funny thing is using this format looks like it's the easiest thing to do, because using this format here, if you throw a 0 there, it's also fine. It doesn't matter whether you use this format or this format. It really doesn't matter. So our argument here is that the X value of A is 0. The Y value we don't know, you see. So we're going to take A, we're going to throw it in there. So wherever X is, going to throw a 0 there. Minus 6 with a 0 there. Y squared minus 4y is equal to 12 is what we have left over there. And then you only have y squared minus 4y is equal to 12. So you may be thinking to yourself, okay, fine. We now have an expression for like the y value of A. That's technically what you have here. You have an expression for the y value of A. So here you basically have an equation where you can solve for y. Solving for y here, it's really not going to be an issue, because you can just take the 12 over, becomes a negative. Factors of 12 that give you a 4. In this case, because there's a 1 in front here, it's easier to factorize questions like this, because here you just want factors of 12 that give you a 4. Of which factors of 12 that give you a 4, it is like what? 6 and 2, right? Because 6 times 2 is a 12. But then, or rather, let's say, for you to get 12, it's 6 times 2. But then, because this is specifically a negative 4, you need to say the big number has a negative, the small one has a plus, because negative 4 plus 2 gives you a negative. Negative 6 plus 2 gives a negative 4. So you're going to put y here, y here. So this has given us the two possible values of y, because you see we have thrown in an x value for 0 in our equation. So obviously you're saying, where is the circle equal to 0? It's equal to 0 up here, and it's equal to 0 down here. So you see that's an x value, that's a y value here, that's a y value down there. So clearly here we're getting that y is equal to 6 or y is equal to negative 2. So it's a no-brainer. The one that's a positive is up here, the one that's a negative is down there, right? So now we have the y value of the x and y value of A, which is good. So since we're looking for the equation of BA, we obviously do need to get the gradient of that line. And point B, yeah, you may be thinking to yourself, okay, what are we gonna do for point B? Well, we could use the distance formula from no, never mind, forget that. Try and avoid using the distance formula where you can, because the distance formula is just so much work unnecessarily, legit though, legit. So in this case, the best thing is, luckily, you want to think outside the box. Not think outside the box per se, but anytime you're dealing with something that's a tangent to a circle, as they say it up here, you see, that's why your description, always go back to it if you need to. Because it's a tangent, you know that this angle here is equal to 90 degrees, because we know our laws. So obviously if you get the gradient of AC, you will automatically get the gradient of like a b, because they are just being multiplied together gives you a -1. So let's actually use that, to help us. So here we know that the gradient of BA multiplied by the gradient of AC, this is equal to -1. The gradient of AC, we can just use the gradient formula. You see this value here, we now know that it is a 6. Like, we have worked it out. Is not an issue. What you got here? C, we worked it out to be like a 3 and a 2. So the gradient, let me put here, do I write it here or in the, yeah, let me just put here the gradient of AC. This is equal to like y2 minus y1, x2 minus x1, and then what you got here, you can just, it doesn't matter. Let's say 2 minus 6 and then 3 minus 0. Yeah, let's do it. 2 minus 6 and then 3 minus 0. In your, this is going to give you -4 over 3. And then obviously, if you throw this into this formula, right? I feel like I'm blazing through this thing. The boy was like busy chilling from like 1 to 3. Busy chilling. Now, we have gotten the pedal to the metal, baba. Anyways, this is the gradient of BA. We don't have it. But then we're multiplying it by the gradient of like AC, right? Because you see, when you're multiplying something, you can just put it in brackets. This is equal to -1. So you working out BA, you can just divide both sides by the gradient of this number. Or we can just divide this number here, and then can just divide this number here. Put this in the calculator with your brackets and everything. So as the gradient of BA is just gonna be +3 over 4. Like, wow, look at that, you can really dance. So obviously this shows that this question was actually not that bad, because this is the gradient and the y-intercept was a 6, because a value is a 6 there. So here we can say, therefore, y is equal to 3 over 4 with the x here plus 6. I feel like for 8 marks this was quite a fair question, because wow, there's a lot of writing here, but it looks like they plugged us with some marks, like real good. Let's see, 6, and then that's the y-intercept. The gradient here, we got it to be 3 over 4. Nothing crazy too much there. So getting the angle of alpha. Getting angle alpha, don't think too narrow, Looking at things like this, and always try and make sure that you work with an angle at the x-axis first, and then use that to help you get something up there. Don't even focus on alpha, because alpha is too out of reach. What you want to do is just think of getting this first, because if you can get this, you're sorted, because alpha is equal to this green angle plus the 90-degree part, you see, because an exterior angle of a triangle is equal to the sum of the opposite interior angles. So let me actually even write that first, you see. So I'm going to say ABO. Ooh, somebody's hungry. Me, I'm hungry. Like a lion. Yeah, a friend of mine always says that. Like, damn. I have stolen it. So it's A, B, and 0, right? So let's see here. A, B. Yeah, let's say angle ABO. This here is equal to... no, let's just put it this way. Let's just say alpha is equal to these two put together. So alpha is equal to this angle plus 90 degrees. I mean, you don't have to put a reason, but if you want, you can just say exterior angle of triangle. You see, because this alpha here, you want to remember that this line and this line here, you see, there's a straight line here. So this makes this an exterior angle of this triangle over here. So this exterior angle is equal to this one plus that one put together. You see, that's all your triangle laws and stuff. So easily we can get ABO here using the tan formula, because technically tan with angle ABO is representing the origin. So here we know that this is equal to M, which is the gradient of your line, and the line we're dealing with here is technically just AB or BA, or whichever one to call it, because remember, this formula works, it's on your formula sheet, it works with the gradient of this line here that will be cutting this circle. I mean, that will be cutting the x-axis there, you see. So this angle here, we can get it using our tan formula. The gradient of BA, we got it to be like 3 over 4. So this is like 3 over 4. 10 with the whole AB. So to make your life easy, don't even stress about these things here. Like when you put this into your calculator, like if you do this and you say shift 10 with like a negative 3 over 4. Literally, let me just tell you this. This is like it's not a hack or a secret or something fancy. It's really not. When you throw this into your calculator, literally whatever you get, always make sure that you think logically. You see, meaning if you get if you put all that in your calculator and you say you wanted this angle here, when you would have done, if you're doing what you're doing in your calculator, it will always give you this angle sometimes, you see. So obviously for you to get this part, you would just say 180 minus the small one gives you this part, because these are just angles on a straight line. So just always remember, whatever your calculator gives you, always ask which angle do you want. Do you want this one or do you want that one? If you want this one, always make sure you get an obtuse angle. If you don't get an obtuse angle from your calculator, just say 180 minus whatever you would have gotten, because if you get an acute angle, it's obviously going to be for this one. But if you get for an obtuse, which you probably won't, it'll be this one. But anyways, that's the big idea. In our case here, our calculator, if you throw this, it is just giving you 36.87. You see, A, B, that. You see, even if it gave you an obtuse angle, maybe because it's drunk or something, just remove it from 180 and get this angle here, you see. So this angle here, clearly we can say 90 plus that angle to get our alpha. You see, they say that this is like 36.87. So 86.87 plus 90, that's going to give us our alpha based on this, you see. Alpha is equal to 36.87 plus 90. What you got over there? What you got? 126.87 is what you got. Like legit, you know? Because why not? Nothing crazy about this question. Moving on. 4.2 for 6 marks. Oh wow, 6-mark questions. 6-mark questions are interesting, you know? These things are interesting. Don't lose 6-mark questions because you're going to cry. 4.2 says, if another circle with this equation, right? With center D, let's actually see where D is, because when you're reading your description, if you have a sketch to refer to or a Cartesian plane, don't take it for granted. I mean, like, just use it, you know. Where is D? Okay, so there's no D anywhere specifically in our sketch so far, so it means that D is going to be like a new point somewhere. But let's see, let's read nicely and see what they want us to do. Let's read nicely and see what they want us to do. Like, you really don't have to say, okay, never mind. Let's see. It says with center D, right? They say they've drawn that circle. So obviously, if you want to see where center D is, you can just put the circle into standard form. It's really not an issue. At 4.2 now. 4.2 looks like an interesting question. Like, look at it. It's out of 6. I think this one is going to be more interesting than the 8-mark question. But you never know. You never know. It's not like a competition here. That was a dumb joke. Hey, whatever. It is what it is. And I should upgrade my vocabulary, you know, because, you know, people that say it is what it is, it's because they've got nothing to say, you know, they've got nothing creative to say. So I must upgrade myself, otherwise. It says, if another circle with this equation now, so it's a new circle, it has a center D. What you'll notice, there's no D anywhere in our expression so far, you see, so that's okay. It just means D somewhere, you know, somewhere over there. So obviously to find D, it looks like we can easily just put this equation into standard form. It says here, determine with calculations whether C and D will touch. No, determine whether circle C and D will touch. And then determine whether circle C and D will touch, will not touch at all, or will intersect each other. Okay, so for 6 marks, this is quite an easy question. Something like this is covered specifically in the snap. I have the Wi-Fi off, so ish. Ugh, I'm wasting time. Oh, bro. Oh, what? This Wi-Fi doesn't want to open. Oops. Open. Oh, good lord. Anyways, excuse me. I'll just go back there when this Wi-Fi wants to work. So here it says, you need to work out whether they touch, they don't touch, or they touch twice. Or see, it says will touch, will not touch, or will intersect each other. So what they mean is with circles, right, they're either going to touch once like this, or they're going to touch twice like this, or they're not going to touch at all. You see, that's what they mean. So in our case, the issue with questions like that is you just need to work with the centers of your circle. Like if you check on the main channel, right, the BrightYoungBrains main channel, if I go to like the videos, let me go here, your channel, thank you so much. If I go to playlists and I go to like the analytical geometry playlist, if you look nicely here, this analytical geometry playlist, if I open it, there's a tutorial specifically working with what we are talking about here. You see here, it's asking to prove that two circles touch each other. This is the tutorial that talks about what we're about to showcase now. But anyways, here you need to work with the radius of the two circles. So getting the radius of this circle, we said all you have to do is to put your circle into standard form. So obviously, yes, if you're still struggling with putting a circle into standard form, this is like your other chance to see what you can do, you know. So here, the first thing you need to do is the ones with x go together, the ones with y go together. And we say the ones with x, obviously you always want to look for this value here, the one that has x as the variable. So here you are going to add this number over 2 squared, and then for the y you do exactly the same. You're going to see here there's like a negative 4y here, so here you're going to add negative 4 over 2 squared, and then here after the 44 you're going to add these two numbers that you added on the left. So here this is technically 2 over 2 squared plus yay, what is this now? This is like negative 4 over 2 squared. Yeah, come on bro, come on now. Negative 4 over 2 squared. Yes. So here, if you check on the left side, you see on the left side of this expression, you specifically have something quite interesting. Okay, not really that interesting. It's just like a 49. Like if you put everything in your calculator, that doesn't get any more interesting than that, right? I'm like 49, not. Anyways, this is 1 and that's x squared. So we know that this is a trinomial, right? We said this value here, you're just going to put it in with squares, you're going to put it with x squared. And then for the y, you do something similar. This y, you're going to put it with this value, which is just a negative 2. You square everything, because these three are replaced by this bracket, these three are replaced by this bracket. And then obviously, therefore, your value of d is just this here as the opposite, and this here as the opposite. Now you have the center, you see, of d. So all you have to do is to literally think to yourself, if you think of C and D, right, wherever D is, let's see here, negative 1 and 2. So let's just estimate, you know, let's just estimate negative 1 and 2. So that's like negative 1 and positive 2. That's like somewhere here, like for real though. D is like somewhere there, like legit, you see. So if D is like somewhere here, the radius of this circle here is 7, you see, radius equals 7. So the funny thing is, you may think to yourself that these circles do touch, but don't guess it, you know. Don't put yourself in a situation where you're going to guess this thing, you know. So what you do is, for you to find out if circles touch and all that, you literally just need to work with the radius lengths, you see. So these circles, well, they look like they're going to touch. I'm like one way or the other. I'm like, I don't know, but there's the center here, there's the center there. So the idea is, let's use these 3 images here. This is something also covered in like the course platform. So if circles touch only once, you see, this is like touching, zoom out. Let's write once here. This is like touching once. This is like touching twice. And then this is not touching, you see. No touching, people, no touching. Weird. So that's not weird. What am I saying? Busy mixing up stuff. Just let me not get distracted. So here, this is the center, this is the center, ne? So if they touch once, it means that the radius of the one circle plus the radius of the other circle. You see here, radius 1 plus the radius of the second circle. Let's label them radius 1 and 2. So it's like R1 here, R2. You see, if they touch once, then it means that the distance of radius 1 plus the distance of radius 2 this would be equal to the distance between the two centers. So if this is like D and C, you see, if this plus that is equal to DC, then it means they touch exactly once. But then if you have, let's say, C here and you have, let's say, D here, right? Obviously, if the distance between the two circles, like the distance between here, if your value of DC, right, is smaller than the distance between the one radius plus the other radius, if this is happening, they meet twice. If they don't meet at all, it means that the point D and the point C, if you check the distance there, the distance here, right, would be bigger than the one radius and the other radius, you see, because of this small space in the middle here. So if the distance between your two centers is bigger than your radius plus your other radius, then you know they don't touch at all. So that's all we need to do here. We just need to work out what is the relationship between the radiuses added together and DC. So the length of DC, I mean, that one you can just point blank use the distance formula, like hello, you know, hello. So x value is a 1, y value is like a whoa, oops, I feel like I messed up. Oh no, please don't tell me I messed up. Oh yeah, it's okay. -1 and +2, bro. Oh, why? Whoa, what's going on? Ah, snap, did I really talk for that long with D having to have been plotted in the wrong place? Ah, this is so dumb. Oops. Oh well, I mean, what can we do? The boy did flop, but the boy is fixing it. Feel like an idiot, but I'm fixing it. Look at me fixing it. Fixing it. I don't know what the comments will say, but I'll just have to live with it. So -1 is like to the left, and then +2 is like up there somewhere. Yeah, let's just put an estimate. I'm not even gonna draw it. Let me not draw it anyway, because you see, trying to draw it somewhere really messed me up. But D, excuse me for that, but you spotted it earlier, because I mean, you know, that's usually how these things work. So anyways, let me just try and create some space here. There you go. So we said our issue is just getting the distance of DC. So let's do that. Getting the distance of DC, I mean, like, this is where you can shine with your distance formula, since most people like the distance formula so much. But using the distance formula, it's really not a big issue, because it's just throwing your x values and your y values properly here. So here I'm going to say, where is C? Let me write the coordinates of C here, so that we won't have to like keep going back up here. C is like 3 and 2, right? So where are you? C and 3 and 2. Let's do this. 3 and 2, right? So we can start with the x's. You see, this minus that, it's gonna give you this minus 3 squared, and then 2 minus 2. Whoa, really? They have the same what you call y value. What? How did I not notice that? So D is like somewhere here, somewhere, you see. But let's forget about the guessing game, because the guessing game is the game that no one likes to play unless you are really desperate. Then play it, Baba. Play it so hard. You know, play it so hard. But anyways, CD here is clearly going to be a positive. It's like 4 squared, which is like 16, but then square root of 16 is like a 4. So here, if you put all this into your calculator, you're gonna get DC is like a 4. So all you have to do now is to check the distance between the two radiuses. So with the radius here, it's a 7, right? The radius of the other one, we saw it was a 5. So I'm like, you know, so R1 plus R2, this is clearly giving us 5 plus 7, because the radius of the one circle is 5, the radius of the other circle is like a 7, as we have just worked out now. So this is like giving us a 12, you see. So all you have to do is check which of these here qualifies. Because this is a 12, I mean, like 12 is bigger than 12 is definitely bigger than DC. You see, like here, you see the value here is a 12. So let's just throw that there. This is a 12, and then this number here is a 4. You see, 12 is bigger than a 4, so these circles touch twice, you see. Therefore, they touch twice. And again, if you need a rundown on this, then feel free to check out this tutorial. It's in if you just search BrightYoungBrains on YouTube and then go to like the playlist tab, like you see, if you searched BrightYoungBrains, you are going to end up at like the home page here, and then you're going to go to playlists and then just look under playlists. Usually the playlist right at the bottom, that's analytical geometry, and then the last tutorial in analytical geometry, this is this tutorial here of what we have just worked out. But anyways, let us move on to the next question. This is the part where they take away our calculator. Well, we don't need our calculator because we are woke. We don't need it. Let's hope we don't regret that. Well, usually with these questions, you can't use the calculator anyway, so might as well forget about it. It says here A and B are complementary. So you need to know these words. You see, complementary means that they add up to 90. You see, add up to 90. And then it says the complementary angles, and then A is bigger than 0, and then B is also bigger than 0. So they're both positive numbers. And then they say here, if this is equal to 0, calculate by using a diagram the value of this expression. So questions like these are quite common, because 12, 10, A equal to, negative 5. 12, 10, A minus 5, this is equal to 0, you see? So if you put 10A on the left and everything on the right hand side, you're going to see like 10A, this is equal to like what? This is like positive 5, right? Positive 5, and then with a 12 over there. I was about to put over 12 already, but hey, show your steps for the people. Yeah, so obviously here getting 10A on its own. Oh yeah, the reason why you want to get 10A on its own is because that's usually what you're going to use to draw your diagram. And your diagram does not have to be like a Cartesian plane or whatever. It can just be a right angle triangle, but a Cartesian plane makes it so much easier, I guess. So here, divided by 12, you're going to have 10A is equal to positive 5 over 12. So in this case, they said A plus B is complementary. And here it's a positive number and a positive number. So, I mean, you may be thinking to yourself, do you put, well, this is adjacent over hypotenuse, you see. So, this is opposite over adjacent, you see. So, obviously, the debate here would most probably be something like, are you going to put the triangle over here and have opposite over adjacent? Or are you going to put the triangle over here and have like opposite, which is like negative 5 over adjacent, which is like negative 12? Well, clearly because these are both physically positive values, physically, yeah, you may just choose the first quadrant because this is a positive, this is a positive, you see. So let's just use 5 and specifically 12 here, because I mean, look, going up we know it's a plus, going to the right we know it's a plus, you see, and then left is minus, down is minus. So this is our diagram. The idea with this diagram is obviously you want to put your angle of A over there because this is opposite over adjacent because of our trigonometry. So your diagram, always try and make sure that you complete it by making sure that you have your hyperbola. Yeah, let's get the hyperbola here using what you're gonna use. We're going to use Pythagoras theorem, because we love Pythagoras theorem, do we not? Yes, we do. So obviously here, this you can label it R. Most people label it R. So this here, you know that R squared is going to be 12 squared plus 5 squared. And then this is clearly giving you 169 in your calculator. And then the square root of this number is just 13. Don't worry about putting plus or minus because it's hypotenuse value here. Distance is always going to be a positive number. Whew, it looks like you're good to go. So they say get the expression for this. So you may be thinking to yourself, how do we figure out this when we don't have a B anyway? They did say A and B are complementary. So automatically that tells you that A can be here, B can be up there, because complementary angles add up to 100. No, complementary angles add up to 90, bro. So remember, all interior angles of a triangle add up to 180. So 180 minus the 90 leaves you with these two angles being equal to 90. You see, this A plus this B, that gives you a 90. And they told us, you see, they said A and B are complementary. So this is the sketch you want to draw. And knowing what complementary is what has helped us to put B over there. And knowing that A and B add up to 90, and that interior angles of a triangle add up to 180 is also how we're able to draw this sketch, you see. So theory is important, people. Getting this is actually quite easy now, because this expression we can get it from our diagram. This expression we can also get it from our diagram. So here we can say something like, therefore, hey, let's use a white, you know, because I haven't used the white in so long. Like, I haven't used the white in so long. Where's the white? The white here is like 13 sine A. 13 sine A. And then what is this thing here? 13 sine A minus 310 B. Yes, so obviously you just want an expression for like sine A. Sine A is like opposite over hypotenuse, which is like 5 over 13. And then 10B, you know that this is like, what is 10B? Opposite over adjacent. So it's like 5 over 12, you see. And that is that, you know. You're just going to put this expression into your calculator. And obviously the next step here, you're going to get 5 minus 36 over 5 in your calculator. And then this is obviously just giving you negative 11 over 5, like 3 marks, right? And don't worry about how your diagram, you see, that's why they say use a diagram, because that's where the 5 marks are coming from. You see, as long as your diagram is there, your marks are going to be fairly given if you're using a diagram correctly, because your diagram gives you a mark. And then your value of 13 gives you another mark. Your value of sine A gives you another mark. Your value of 10A gives you another mark. So from here, you could just put everything in your calculator and end up there. It'll be fine. It'll be fine, you see. For more questions like these, trust me, you want to check out the course platform. And you can always hit me up on IG if you have like questions like, you know, 6 marks. They want us to solve this question here. So here, yeah, in my opinion, the best course name on the course platform is like the trigonometry course. And this one review really cemented that. I'm like, you have got to see this, like legit, man. Like, you've got to see this, you know. Don't be a hater. Let me show you something. Let me show you something. Look at what this person said. Community posts are on their way. What do my community posts are on their way? I have community posts everywhere. Oh damn, this thing is really scaring me now. What? Oh, sorry, community posts are unavailable on the computer unless it's version of YouTube. What? I haven't updated my YouTube. This is so embarrassing. Like, I was about to show you the comment. I don't know if I should go on my IG and show you the comment. Like, I'm so tempted to just, you know, let me just show you my IG quickly. I want to show you this comment. Like, really, look at this. Look at what this person said about the trigonometry course. Like, open sesame. Look at this. You see, this is like a review on the course platform, specifically for the trigonometry course. You see, it said that this person here, it says here, this is like the email that I would have gotten. You see, you've gotten review by Nicholas Anima on grade 12, on trigonometry grade 12. This is like the course, right? It's the grade 12 course, the trigonometry one specifically. It said here, helped me so much in my purely trigonometry based test today. This course is for all levels. I think I may have gotten 100% for this test. We'll report back. Thanks, Levi. So when he posted this, it was like around the 19th of August. That's why I like, you know, posted a story on my IG. And then on the 23rd of August, the Brody came back to me. He's like, he got 70 out of 70, which is like obviously 100%. And this is his test, you see, like, it's true, people. It's true. So obviously he's enrolled in the all access pass, meaning he has access to everything. And clearly, as you can see, he had like gone through 100% of like the trigonometry grade 12 course. So yeah, man, the courses are making waves. Don't get left behind. Don't get left behind. Don't say I didn't plug you. Don't say I didn't tell you, because no, I just did. I even gave you a whole story, you know. But 5.2 says we should simplify the following expression. Simplifying this expression, we're going to use our reduction formula and all that. So using your reduction formula, 10 300, I mean, like, we can just rewrite it as 10. Always try and rewrite your expressions based on like the closest special angle. So 360 is the closest one. So here we can just say 360 minus 60. And then here you're dealing with cos 90 plus. I mean, like, cos 90 plus will land you in this quadrant where only sine is a positive. So cos 90 plus, you put a negative and then you put a sine x, because remember, from 90, if it's a 90, that's when you change to a sine, vice versa. And then because you're dealing with cos, 90 plus lands you in the quadrant where sine is a positive. So here you have to put a negative. You choose your value. You choose what you put here based on where you're coming from, not where you end up at. You see, at the bottom, let's see, sine x, I mean, like, ain't gonna do nothing with sine x. And then here, be careful. You know that if you remember, we know that cos with any angle is the same as cos with that angle as a negative. You see, this is like just a rule of thumb. Just a rule of thumb, you see, because if you're using a Cartesian plane, if you say positive x, you end up in this quadrant where this is a positive. Cos is a positive here because everything is a positive. If you go negative x, you end up in this quadrant where cos is also a positive, you see. That's why these two are equal to each other, because they are both just positives. So here, this is just a positive. It's just positive 2 cos 30. Nice. So this is being a 6-mark question. These questions are usually the easy ones because, I mean, like, they're just giving you a lot of marks for, like, just doing basics. So 360 minus, it's just 360 degrees minus. You end up in this quadrant where cos is a positive. So it's going to give you a negative 1060 minus sine x. At the bottom, we can now actually deal with, let me just rewrite the bottom for now, because I want to deal with the numbers all at the same time, you know, because, yeah. So here you need to draw your 30-60 triangle. Drawing the 30-60 triangle, the one thing that I always say is, just remember what sine 30 is. You see, sine 30 is just a half. So if you can remember sine 30, you know that there's a 30 here. And then opposite of hypotenuse is like 1 over 2 there. So opposite of hypotenuse, you see, sine 30 is opposite of hypotenuse, which is a half. You see, sine 30 is a half. So as long as you can put this here, you see, 1, 2, here you put a square root of 3. You see, 1, 2, 3 with a square root. And then obviously, because this is 30, you're going to drop a 60 over there. Drawing this triangle is really not difficult. Like, you can remember how to do many things. Doing this is just easy. So anyways, negative 1060 is opposite over adjacent, you see. So here you're going to be negative, it's going to be negative square root of 3, because square root of 3 over 1 is just square root of 3. This value here, you're minusing. Remember, you're not multiplying, you're minusing the sine x. So don't make the mistake of, like, multiplying those two things. At the bottom, you also have what? Sine x, and then plus, what's cos 30? Cos 30 is adjacent over hypotenuse. So here it's like 2 with adjacent over hypotenuse. Oh, this is nice. At least the 2's are going to cancel out. So yeah, this 2 is going to cancel that 2 down there. At the top, we might as well take out a negative as a common factor, because the bottom part looks like it's going to need us to do that, you see, because the bottom part now is at least going to look like the top. So the thing is, because this bottom part and the top part exactly look alike, you see, this whole thing here, you factorized it. This whole thing here, I mean, like, pretend there's like a 1 out that you took out, you see. So this is factorized, this is factorized. It's together, this is also together. So obviously, you can now cancel the top, and you can then cancel the bottom, and then get an answer of like positive 1. You see, you're canceling. Don't worry about the plus here. If it was just like this and this, this and this, you cannot cancel it. But then this is packed in a bracket, this is packed in a bracket. So that's why you can cancel there, because it's the whole thing that looks like the bottom part. As well, you see, if it's a plus, it doesn't matter. Those things can be swapped around. So for this question, it was quite interesting, you know, quite interesting. But anyways, let's move on to 5.3.1. It says here, for 3 marks, given this expression and this. Oh, this is from your formula sheet, like, duh. You see, this is just like compound angle stuff. It says here, use this identity to derive an identity for cos x plus y. Oh man, really? A proof for this thing? These guys are boring, you know. These guys are boring, Joe. Like, Legit, Joe. These guys are so boring. Like, why did they have to do that? Well, this is actually quite simple, né? For cos x plus y, just remember your reduction formula. You see, when you're dealing with cos, it's the same as sine 90 minus whatever angle this is. You see, this is the same as sine 90, and then you minus whatever the angle this is, minus x plus y. You see, like that. So here you know that cos, let's put here cos theta is the same as sine 90 minus theta. You see, so that's the analogy we're using here. Now the big idea is you're going to use what they've given you to work out what they want. You see, you're going to use this here to break this up. You see, so here we now know we have sine 90 minus, don't multiply inside the bracket. You see, like, you're just going to be making your life a bit difficult. Are you going to be making it a bit difficult? I don't know. I'm like, to be honest, it does seem like you will be making it difficult, but at the same time it's like, are you really going to be making it difficult? In my opinion, it really doesn't look like we're going to be making it difficult. But as a trick, remember, this is a proof, so it's just like steps that you need to follow. And the steps that you follow is that here you multiply the negative inside, né? You're going to have a negative x, you're going to have a negative y. But then the funny thing is you want to end up with an expression where you have a plus in the middle. So you ending up with a plus in the middle means that you have to take out a negative here. You see, if you take out, not to take out a negative, here you have to group them separately, in the sense that you have to group this one with the x, you have to group this one, you put it on its own. So this here, you're just going to write it. I know it's going to be a bit strange, but you're just going to have, this is how you, it's just like a proof. So just remember this step. Put the 90 and the x together. You see, 90 minus x. Put these together. See, I might as well put that in brackets. And then this one, just put it on its own. You see, and then put a plus in the middle here. You see, that's just the proof for what we're doing here. It's just a proof, so don't panic. It's actually quite simple, because as long as you can write out what we have written out here, you're somewhat home free. You're somewhat good to go. Because that, remember, when you're doing proofs, you don't want to cram anything, or you don't want to like come up with your own ways during the exam. You just basically want to do what you know to do beforehand. You see, so here using your formula, you already know that sine x plus y is the same as sine x cos y cos x sine y. So here you're going to put sine x. So sine x in this case represents sine with 90 minus x. You see, that's, this part here is for this part, and then cos y is clearly cos with the negative y over there, cos with the negative y over there. So this is going to be a plus in the middle, and then when we see cos x, we know it's cos in this big bracket there, so it's like 90 minus x, and then sine y, so it's like sine with this value there, so it's like sine with a negative y, sine with a negative y. Great. So obviously here now you just can just do your gymnastics, you see, because I mean, like, use your reduction formula. You see, 90 minus is the same as like cos x, and then cos negative y is the same as like cos y, because remember we said anything that's a negative here for cos, it's the same as a plus. Here cos 90 minus, I mean, like, it lands you in the first quadrant, which is where everything is a positive. Here you have to be careful, because negative sine negative value is going to give you a negative sign that value, you see. So if you simplify here, you're just going to have cos x cos y plus, no, this is going to be a minus now, because you see a plus here times a minus gives you a minus over here, and then you're done, you see. So with this kind of expression that you need to prove here, just remember this step. This is the essential part, and you can do this for other cases that are similar to this. You see, just make sure that you end up with what they've given you. Where x is, it's represented by this bracket. Where y is, it's represented by this. Okay, so that's why this is just a 3-mark question. So know how to do these kinds of things, so you don't lose marks. But let's move on. For 3 marks for proving this now. These people, these guys, they're asking for too much here. It is too much now. How? It is too much. But luckily these are both on your formula sheet. Like, don't even worry about how you are proving something here. This is literally something on your formula sheet, something on your formula sheet. So you may be thinking to yourself, okay, do we just expand those using our compound angles? Yes, exactly. Just expand them using your compound angles. Like legit, on your calculator, or in your formula sheet rather, cos a value minus another value is the same as like cos that value and the other one. Because there's a minus in the middle here, you'll have a plus over there, and then it's like sine x sine y. And then remember, don't forget this minus. You might as well put the whole thing in brackets here. Here it's gonna come out as like cos x cos y. Because there's a plus here, you're gonna put a minus over there, sine x sine y. There you go. And then the best thing you can do for yourself is to like multiply on the inside the brackets. You see, just multiply inside the brackets. So you're gonna have cos x here, cos y, and then you're gonna have sine x sine y. If you multiply inside, it's like negative cos x cos y with the plus sine x sine y. Yeah. And then good, look here, these things cancel each other out. You see, I feel like this paper just making us write a lot. Like how so much writing. So here obviously you see this and that, it's two of them, so it's sine x sine y. Yo bro, just write nicely. I'm not capable. Okay, I'm very capable of anything, even writing nicely, if I really try hard. But anyways, it's just a 3-mark question. You would have proven what they wanted to see. So don't overthink things. Don't think that they want you to come up with a formula of or whatever. Here they just said prove that this is equal to that. So we have proven it. The next one. Oh, anything that starts with a hence means go back to the previous question. Always use what you would have worked out in the previous question for a question that starts with hence. If you don't do that, it's your fault, you know. So here it says hence or otherwise calculate the numerical value of this. I mean, just looking at it, right, it's so clear that this is representing 2 sine x with sine y. Okay, so my suggestion is you already can think to yourself, I mean, this here, this x, you can already see here, x here is equal to 195, you know. We can observe it. What I don't even know what word I'm thinking of. I don't even know if it's a real word. Observantly. Wow. Let's not try and make up stuff or think of stuff that may not exist. So just by inspection, right, you can see that x is 195, y is like 45. You know, by inspection we just mean you are seeing it. You see, where this is, there's a 95. Where this is, there's like a 45. So obviously what we now know is, here we know that 2 sine with the 195 equal, no bro, write nicely, man, come on. No, what you doing? No man, no. So sine 45. Okay, I've got to tell you something. I know I'm off ramping. Okay, no, I'm not off ramp. I'll off ramp after I finish this question. So this here we know it's equal to the left side here, right? So obviously what that means is this here we can say it's equal to cos with x minus y. So the x we can put the number we know, the y we can put the number we know. So this is going to be cos x, we said it is 195 minus 45 over here, and then here it is what you got, man. Show us the goods. That sounds weird. Oops, sorry. This is a minus, and then you're gonna put a plus there. So this is like minus cos, and then 195 plus 45, like that. You see, good. So here you can just simplify on the right side. This minus that, I think is gonna give you like, what is it gonna give you? Is it like 150 or something? Yeah, I think it's gonna give you like 150, and the other one is gonna give you like 240. So here this is like cos 150 minus cos 240. So these numbers, always try and write them in terms of like special angles. Like here, the cos 150, I mean, like you can write that it's close to 180. So this you can just put 180 minus 30. And then the other one you can put the cos 180 plus what? Plus 60. And then what else you got? This is yeah, 180 minus, I mean, if you use your cost diagram, or 180 plus, I mean, like, this is quite easy. 180 minus lands in this quadrant where sine is a positive, so this is like sine 30. And then don't put this yet. So 180 plus lands you in the quadrant here where only 10 is a positive, so this would come out as a negative. So let me just put minus here with minus cos 60 so that we don't get confused, you know. And then sine 30 plus plus what? Plus cos 60. This here we can just use our special triangle now. If you have it drawn somewhere, I mean, like, use it, you know. Yeah, let's actually even copy it, because I'm like, why not, you know, like, why you gotta do the same things over and over? At least they didn't say you cannot use your calculator. Oh, they did say in the beginning of question 5. So you can just show this diagram here. Cos 30 is a half, as we already know. You already know. Now I'm a whip. Now I'm in. Now watch me whip. 2014 was lit. So this is cos 60. Cos 60 is like adjacent of hypotenuse. So it's like a half plus a half. What does it give you? 2 halves. What is 2 halves? It's 1. It's a 1. I feel like in grade 1. Oh, no, this is definitely wrong. I made a mistake. How did I end up with sine? Oh, no, sorry. I'm sorry, peoples. I'm sorry. I know you probably spotted it first, and which is cool, but me, I didn't, you see? Me, I didn't. I don't know why I put a 30 cos there, a sine there. It's just, you know, it's just a mistake. But anyways, this is the correct one. I'm not editing it out so that you can see that, sometimes, yeah, it doesn't just come out. So here, this is adjacent of hypotenuse. That's like square root of 3 over 2. If you add this up, you're going to get square root of 3 plus 1 over 2, you see. And then that will be that, you know. Don't gotta do nothing. You don't have to do anything, you see. But then I feel like there's a negative somewhere. Yeah, this is a negative. Is this a negative? 180 minus, yeah. You see, I even forgot a negative. Hey, what is wrong with me? I feel like I'm bombing out. I'm sorry. Oh, I'm so sorry. Oh, am I? I really am. I'm really. But we're fisking it. That's like dumb. Fisking what? What does it even mean, bro? Like, speak properly, bro. Come on. Like, legit. Hey, let's move on to what? It's question 6 next, so let's do that. Question 6. This is pure trigonometry now. We're in trigonometry territory. So that trigonometry course that I spoke about when I started talking about, you know, when I was starting with the previous question. The trigonometry course, I mean, like, it's on the course platform. You see, everything is on the course platform. Because the trigonometry course, the reason why it's a personal favorite, I really don't know why, but all of them are good, but you can see there's just something about the trigonometry one. Maybe because most people struggle with trigonometry, so yeah, when that course is like, when anyone goes through that course, it really helps. So anyways, this is the trigonometry course. I would say the best way to, you know, access the courses is via the all access pass, because you access everything all at once instead of like doing it one and stuff. So here you see it has 5 chapters. You see, it starts with proving identities and simplifying trig expressions, and then how to answer general solution questions, solving trig expressions using diagrams and sketches, which is what we just did right now. And then this is working with trig graphs, which is what we're about to do now. And then 3D triangles is what comes afterwards, which is also like how an exam paper is like set up, you see, like on the trigonometry side. But anyways, here we are. It says in the diagram, the graph of this is f of x. Yes, looks like it's a, what? This is strange. It's a strange looking sine graph. Oh, it doesn't. It's not strange, actually. It's a normal sine graph, but we're only seeing a portion of it. So it says here, this is a normal sine graph. The amplitude is a 2. You see? Let's not forget that. We can even see it here. Secondly, they said this is in the interval negative 90 to 270. What is negative 90 and 270? 270 is like there, you see. Anyways, what you got? So yeah, this here is, you know, 1/2 of the sine graph, and then obviously the other one would like end, so the full graph would like end somewhere there at like 360, but we can see that ours is like ending at like 270, which is okay. So that's why they have given us this domain here. You see, we're seeing it from negative 90 until 270. That's okay. Here it now says for 3 marks, draw the graph of G, which is like negative cos x plus 30 for the interval where x is like between negative 90 and like positive 180.
So anyways, for 6.1 specifically, it says there, draw the graph of G. What does the graph of G look like? I mean, like, we just need to draw the graph of G. The graph of G, it's a cos graph that is moved 30 degrees to the left. So I guess that is important. Like, I'm not I guess, I'm like, it really is important. Like, you know, it's like a grand piece of information that they've given us there. So it's a cos graph that's been moved 30 degrees to the left. So let's not forget that. And then it says here for the interval negative 90 to 27. So I'm just going to draw it here, you know. It says in your answer book, you should write in your answer book, show all intercepts with the x's as well as the turning points. So the key thing is, when drawing a graph like this, right, always just remember what a standard image looks like. So let me draw a standard image first, you see. Y is equal to cos x would look like this, you see. Up here would be a 1, and then from 0 to 360 it would look like that, you see. Obviously on the left it would look like that as well. Now the key thing that we want to spot is these values here. You see, up here would be a 1 where this is a 0. This would be like a 90, this would be like 270, this would be like 360. And then obviously this is like negative 90, and then like negative 270, and then like negative 360. In the middle, that's like negative 180. In the middle, this is like positive 180. So obviously this graph was moved, a standard cos graph here was moved 30 to the left. So let's put here 30 to the left. You see, 30 to the left is what we're working with. So if a standard cos graph was moved 30 degrees to the left, let's see here, let me close this. And let me close this over here. If it was moved 30 degrees to the left, then it means that all these key points here would move 30 to the left. So let's start plotting, you know, instead of talking, let's start plotting. So obviously this positive 1 here, instead of it being at 0, it's going to be at like negative 30. So here, somewhere at negative 30, you're going to have a point over there. And then you see this 90 here, it's going to be at 60. So you're going to have a point there at 60. And then this 270 is going to be somewhere at like 240. So where's 240? It's going to be all over there. Nice, you see? And then obviously, I mean, what's going to happen at 270? Well, at 270, it's going to be like a curve that's like, that will be going up and stuff. So, well, obviously the turning point is at like 180. So this one is going to be at 150. Specifically down here at 150. And then let's just connect what we have so far. So this, you can see it's going to be like a curve. You don't have to do it all in one go because you're not a robot, you know. You're not a robot. I'm not a robot. It's like K-pop. I watched like half of it. And then I was just like, yeah, no, it is what it is. Let's do that. And then here, obviously, this is the turning point. This is the turning point. So your graph, you know that eventually at, let's see where the other thing, here it was at 360, you see. So backwards would have been like at 330. So somewhere at 330 would be like maybe somewhere there. So don't make it go all the way up there. Just make sure it's like, you know, try and make it symmetrical. So somewhere there is how far it will be, you see. Because this point here, you see, it's going to be like that. And then here, try and make it symmetrical. So here, you know that it's going to be like somewhere over there, you see. Drop it like that's how you see it. Because this point symmetrical to that point, this point symmetrical to that point, this point symmetrical to that point. You see, make it curve. You can actually label this. This is just g of x. They say we should show all intersects with the x-axis. So this point we have there. We don't know what this value is actually, but I mean, like, what did they say? They said here, show all intercepts with the axis as well as the turning point. So in terms of you getting this actual point, I mean, like, you know that the x value is a 0, you see. So you can just throw 0 into your into your equation. So here, g of x, if you throw a 0 in there, you're going to have cos 30. And then in your calculator, cos 30 is going to give you, let's just use this triangle. Cos 30 is adjacent of hypotenuse, so that's like square root of 3 all over 2, you see? Square root of 3 over 2. Nice. This is 60, we can clearly see it. This is 240, we can clearly see it. Those are all the intercepts with the x's. We have shown them everything. They'll happily give you 3 marks for this question over here. So what did I say here? Square root of 3 over 2. Perfect. So let's see here. Question 6.2. 6.2 for only 4 marks says show that this is equal to that can also be expressed as that. Well, it's just like proving an identity. Well, it is proving an identity. It's a question that's asking us to prove an identity. Like, hello. That was not necessary. Or was it? I don't know. We have said it. We're moving on now. So showing that this left side is equal to the right side. It's obviously nothing crazy, nothing major. It's just, it's just basics. Or is it? Let's find out. So with cases where you have a compound angle on the right side, always make sure that you change this to like sine 90 something. Or what I mean is, right, funny enough, if you check in the trigonometry course, well, let's see if you're enrolled into the trigonometry course, or if you've like signed up for like the all access pass, what you'll note is when we work with questions like these, right, the one thing we have basically stated is that you want to don't overthink it, just simplify. You see, thinking outside the box here, we can just use our compound angles. You see, like on the right side, let's just use compound angles. This is like 2 sine x, this is just cos x cos 30. Because it's a plus here, it's going to be a minus sine x sine 30, and then you're good to go. You see, sine 30 cos 30, we said it is like square root of 3 over 2. Let's put it in front of the cos x. Cos 30, we said it's a half, so let's put it in front of the sine x, and then this is like 2 sine x. I think it will be best to put the stuff with the sine together. You see, if you move this over, it's going to have 2 sine x plus a half sine x. This is equal to square root of 3 over 2 cos x. Nice. This is moving along quite nice, actually. So obviously 2 plus a half is like 5 over 2 sine x equal to square root of 3 over 2. So what you're going to do here, clearly you can introduce a tan into the expression. You can introduce a tan by dividing both sides by like a cos. You see, cos x over here, cos x over there. So the funny thing is, don't worry about this. This is just this divided by 1. It's just the same as like 5 over 2. But this divided by that is a tan x. You see? Ha ha ha. And then this can just cancel each other out. You have like square root of 3 over 2 there. And then now you just want to work out 10x, you see. So don't panic. It's a fraction and all that, but you're still just going to divide by its coefficient on both sides, you see. On both sides, you're just going to divide by 5 over 2. You see, 5 over 2 there, 5 over 2 there. This cancels that. This is just going to give you 10x is equal to square root of 3 over 5 in your calculator. Now we can do what we want. Oh, no, we're done. Wow, legit solved it by mistake. What a wow. Anyways, let's move on to 6.3. For 2 marks here, they said, hence determine the values of x to 1 decimal place where they are equal to each other. So this is just like getting the general solution. I mean, this is getting the general solution. I mean, like, technically, all we've done here is we've done like 80% of what we would do when we need to get the general solution. I mean, where f of x and g of x are equal to each other. F of x, we know it is just 2 sine x. G of x, we know it is just cos x plus the 30. I'm like, that we know. So when you equate these, you ended up with like 10x equal to square root of 3 over 5. I'm like, why not just start there? Let's start there. Do we have money? Anyways, let's get the general. Let's get the reference angle. The reference angle. So from here, you're going to say a reference angle is equal to shift tan with this value. Remember, if this value was a negative, you were always just going to take it as a positive value. And then your cast diagram is what you use the negative or the plus for. Like here, our reference angle, what are we getting our reference angle as? Our reference angle, well, I have to get a calculator now. And I really did not want to do this. I really did not want to do this, like for real though. I really did not. But our reference angle is just 19.1, thank goodness. So 19.1. So here we can clearly see we need to work in the first quadrant. Working in the first quadrant, you just carry on from here. X is equal to whatever this is. Because you need to get, they didn't say get the general solution, they just wanted to work out where they meet. So this is just 19.1. Let's double check if that's like viable. Yep, that does look like 19.1. The other point where they meet is like somewhere here. So we want like something in the 190s and stuff. So let's see if we can get that here. Where 10 is also a positive is the third quadrant, which is 180 plus. So third quadrant is going to be x is equal to 180 plus the reference angle. And then this is going to give you 199. Is it 199.1? Yes, maybe. Yes, it's 199.1. And then that is that. You see, that's why there's a 2-mark question here, because there's really nothing to it. They didn't say get the general solution. That's why we're not putting the plus K360 what. Because the plus K360 parts, they also give us other solutions, like going to the left and going to the right. But anyways, let's just move on. 3 marks, they say it here, for which use the solutions you obtained in the previous question. Yes. And the graph the graphs that you drew, or the graph that we have, to determine the values of x between 0 and 270. This is very important. They're saying between 0 and 270. They want you to work out where is f of x multiplied by g of x, giving you a number that is smaller or equal to 0. So if you've gone through the inequalities playlist, you've gone through these kinds of questions, because these are the kinds of questions that we worked on in the inequality playlist. So if you check on the channel now, if you go to playlists and you check the inequalities playlist, let's scroll down here. Where's the inequality? There it is. You see, if you open this inequalities playlist, you'll see here we work with inequalities. You see, if you look at this thumbnail, we're working with inequalities for tree graphs as well and all that. So I suggest you go through those if this is not, your cup of tea. And then obviously questions like these are like, in the functions and graphs course, we went through them like nobody's business. But the idea with questions like these is that you're just gonna have like, this is an expression for f of x. So this is like a y value of f. This is a y value of g. This will be a negative if this is a plus while this is a minus, or if it's the other way around. You see, so this is just a negative, this is just a positive, this is just a y value. So they're basically asking you, where will the y value of this times the y value of that be a negative? And we know that this will only happen if this is a plus while this is a minus, or if this is a minus while this is a plus. Obviously, them equating to 0, it just means n of them can be equal to 0. But the equal to 0 part, that's actually the easy part. So we don't actually need to worry about that until right at the end of the question. So when they say you use your sketches to answer this question, this is what they mean. All you do is, looking at your picture, let's see this image here. Yeah, let me actually write the question up here. You see, they said where is f of x times g of x, where is this smaller or equal to 0? So if you look at your equation, your picture from left going to right, you want to look for a case where they are on opposite sides of the x-axis. You see, you want a case where one has positive y values while the other one has negative. And you want to look for cases where one has negative y values while the other one has positive y values, you see. And here you see this does not qualify because this has positive y values while this has positive y values as well. And then only until here do we have this down here, you see, while this one is like up there. You see it? You see this part here, you see this has positive y values, this has negative y values. So this portion here forms part of our answer. And so part of our answer here, we're going to need to say that x is an element of 60. We're going to include 60 up until positive 180, and we're going to include 180. The reason we're including 60 and 180 is because those are cases where this is just one of the answers that we need to put down, because here you can already see at 60 one of them is equal to 0, so 0 times anything is going to give you a 0. At 180 one of them is equal to 0, so 0 times anything is going to give you a 0. So that's where this comes in, you see. The other portion where this has positive y values while the other one has an opposite is here, you see. This has positive y values while this one is having negative y values, you see. Always look for things like where the x-axis is, because that's where obviously one will have negative y values while the other one is like positive. So here this is like 240 until like 270. So your other answer, we're going to say, oh, x is an element of 240 going until 270. 240. Snap, man. Come on, bro. Hey, let me actually just take this down there again, because we are done here. We just wanted to see the sketch. So let's copy, or rather let's cut, because why not? Why not cut it? Cut it, maybe. Got it. Throw it down here. So our answer, we said it is this, or from 240 to 270. So or x is element of 240 until 270. Yeah, see. There we go. That is good. That is good. It's a 3-mark question. That's how you work it out. This kind of a question is almost similar. Here you just want to work out where the y values of f above or equal to the y values of g. You see, y values of f, y values of g. So the big idea is you still use the same image, you see. You want to look for a case where the y values of f are above the y values of g. So that's kind of easy, because, but then you have to remember they're only taking from 0 going to 270. So y values of f is the one that we were given. So y values of f, you can already see here, these y values of f here, they are higher than the y, no. These y values of f from here all the way until the other side down there. You see these y values here, they are above the y values of g over there, because you see these y values of g, they are lower than the y values of f over there. Where they meet, that's where things swap around. You see, now f is below and g is above. Here, now f is below, g is above. So they just want us to get a point where f of x is bigger or equal to g of x. You see, so that is happening from this point, which is why this is important. You see, we got it to be like 19.1. This, we got it to be like 99.1, you see. So in terms of giving our answer, we're going to need to say from this until that, where they are both included, because this is where they are equal, this is where they are equal, and then this is where the graph of f is above. So we're going to need to say x is an element of 19.1 all the way until 199. So these questions, they're quite standard, and you can see this is how you work them out, you see. So just know your theory, just know your work. You will see that these questions, they're not like madness or anything. You see, they're not trying to kill you. So anyways, let's move on to question number 7. Okay, question number 7, people. Question number 7. This is what question number 7 says. It says, in the diagram, C and D represent 2 boats. Ooh, got a boat over there. Got a boat over there. Nice, very nice. And then it says here, there are 2 boats in the same horizontal plane. So clearly, they're on the ground. Or technically on the water. Hey, who knows? Maybe they're boats with wheels. Maybe they're being towed by cars, you see? Yeah, don't rule out that scenario. You know it's a valid one. Anyways, it says these 2 boats are in the same horizontal plane as B. So B is a point. This is a boat. This is a boat. And then it says here, same horizontal plane as B, the base of the lighthouse. Yeah, maybe they're driving to the sea, you know. So this is the lighthouse. Well, they're probably in the sea already, but hey, it doesn't matter. It says here, this is the B is in the same horizontal plane as the boats. So these are on the ground, you see. And then you have it says here the height is h, okay, and both C and A are equidistant from B, so this is equal to each other. So obviously this is an isosceles triangle, meaning that this angle here is equal to that angle there. I mean, like, don't take it for granted. And then they said here the angle of elevation from C to D, no, the angle of elevation from C and D to A is x. Oh, excuse me, bro, you're yawning. You're yawning. I wonder if somebody else yawned. I think they did. So obviously this video is like helping and you've gotten this far. Just give it a like, man. I'm like, if you have gotten this far and you don't like it, you know how to endure pain. But I'm pretty sure if you've gotten this far, it means that it's popping, you know. So just give it a thumbs up. Anyways, the angles of elevation from C to A and D to A are both x, yes. And then they said here, so these are obviously similar triangles, these ones. If not similar, they're actually congruent because they have a side that's common and they have another side that's equal to each other. You see? Yo, goodness. Come on, bro. Come on now. Yeah, let me just leave that one out because it doesn't want to be there. So these are congruent because there's an angle and the angle that are equal, and then two sides that are equal. Because with congruency, as long as it's not three angles that are equal, but three things of those two triangles that are equal, then the triangles are congruent. Congruency means that everything is equal. It automatically just means that we know that this angle now, whatever it is equal to this angle over there, you see. So let's just maybe put lines there just so that we don't get cluttered. Okay, they told us that CBD is Y. Oh, CBD. CBD is Y. So let's give it another color because why not, right? We have like so many colors to choose from. Anyways, for 6 marks, they said the following. Prove that CD is equal to this expression. So the one thing I always say is, when you work out questions on proving, this is also something that we covered there are a lot of places where we covered this, but obviously the one thing I can also recommend, right, is if you're keen on maybe getting tutoring and stuff, just also maybe you can try enrolling yourself into this package here, because this package here, you see, this is like Zoom recordings of the sessions that I have, and remember those Zoom recordings, it's like full sessions, so you do have very interesting and normal questions. Like here, this is explaining a 3D triangles question. It's a full exam style question, this one. So it's like they'll as of this recording, you can only see there's like 48 something lessons, but these are like full lessons and stuff. But over time, I mean, like by the time you're watching this, maybe there's like 100 or something in there. Who knows? I don't know. But anyways, here, because that's like a fairly new package. So when we answer questions like these, this is what we say you need to do. Try and focus on where information is in your sketch, and also looking at what you're trying to prove. Look at things like this. You see, there's H here, but then H is all the way in there, in one of these triangles, and then there is cos Y over here, but then okay, Y is in here. That's good. And then there's 10x, and then x is in this triangle. So obviously it means we can either use this triangle, this one, to help us to get information in this triangle here. Always use information from one triangle to get you information in another triangle. And because our expression has h and y, you want to eventually have all that information in like one triangle. So you may be asking, why don't we just have the information in this one and get what we want? Well, because they're asking for CD, it's best if we have information in this bottom triangle, because look, the two things that are going to help us. Ooh, somebody's hungry. Anyways, here, this is a right angle triangle. This is B, this is A, this is D. There's X over here, there's H over there. There's BD there. That's the link to this triangle at the bottom. Because anytime you're working with triangles, always use a common side to help you get information from one triangle to the other. So you see, this is a common side here. There's Y here, this angle is equal to that angle, that's fine. The issue is, for you to get information from this triangle to this triangle, just work out an expression for BD. Don't worry about how you don't have numbers and everything. That's why people usually get it wrong with 3D triangles. They want to use things that have numbers, of which that's the wrong approach. Don't worry about not having numbers. Just worry about having expressions that you can like work with. So here, I might as well paste this here, maybe make it a bit smaller, and maybe put it in the corner over there. And let's work out what we need to work out. Let's work out an expression for like BD. It looks like we can just use normal trigonometry because this is like adjacent over hypotenuse, you see? No. Opposite over adjacent. Wow, bro. I think I saw H and I was like, oh, hypotenuse. But it's like, no, this is hypotenuse. But anyways, here, we can say 10x is equal to opposite over adjacent. You see, opposite is H and adjacent is like BD. We want an expression for BD because that's the link into the other triangle. So let's do that. BD here, you can just cross multiply. You're gonna have 1 times that, which is like H. BD times 10, it's like BD 10x. And then, yo, bro, come on, write nicely, man. Write nicely. You know, no one is going to beat you if you write nicely, like for real though. Huh? Divide both sides by 10x, you're gonna have BD is equal to H over 10x. So you see, so far so good, because I'm like, that expression is already there somewhere. So don't even worry about what they're asking to prove until you're like almost at the end or something, because here our focus is just, you see, in this triangle now, we have a value of H over 10x. Don't forget that they told us that the other side is equal to this as well. Let's put H over 10x as well. The reason for doing that is, clearly you can see that we can just use the cosine rule for this. Because remember, the cosine rule requires you to have an angle here, a side there, and a side there. You see? And then you need to be working out the opposite value over here, which is, in our case, the CD. It all makes sense because you can already see there's like a cos here somewhere. So, where there is fire, no, it's like where there's smoke, there's fire. Lol, or somebody baby. But anyways, we never know. But let's see here. Your cosine rule, it's like a squared is equal to like this, and then minus 2bc cos a. We know that this just goes with that one. You see, this will be your angle there, this will be your side over there. So in our case, we have the angle y, right, and the side CD. So let's put here CD squared is equal to one of our sides and the other side. So it's going to be H over 10x squared plus another H over 10x squared. And then we're minusing 2 of these yeah, you see. So here I'm going to put 10, let me just write it out just so that people don't get like, you know, confused. And then the angle A is like Y. Here you can just simplify nicely. I'm like, if you've gotten this far, like you're home free, this and this, it's 2 of the same thing, you see. So don't panic. You have gotten so far. Just carry on. Don't make the mistake of forgetting that this is attached to the cos. So these two cannot mix in any way. So this times that is just going to give you 2 with H over 10x, the whole thing squared. Because it's 2 things that look alike there. You're multiplying them. Don't say this minus this, they cancel out because of the cos y there. I have seen many people do this and this. It's like so wrong, man. Because it's, you see, this is cos y. This does not have any cos y on it, so these two don't match or don't mix at all. What you can do here though is you can take out this as a common factor, but at this point in time, I think this is where you can start looking and seeing what this looks like. So looking and seeing what this looks like, we can clearly see that the H, whatever, that looks like it was taken out, you see? So use that as a hint. So let's take out the H squared, what only. So let's take out H over 10x. You see, that's, you see, remember when we said, try and only look at what you are working with right at the end, because you see, sometimes it only works right at the end only. So if you take this out as a common factor, inside your brackets, you're going to have 2 left minus 2, and then cos y. So I think the reason for doing this is because when you now use your third laws, the square root of CD squared is just this is gonna cancel that. However, the square root of this whole thing here, your third laws basically tell you that, remember, if you're multiplying stuff, and you put them under a square root symbol, the square root symbol basically goes for what? For both of them individually, you see. So here you're going to say the square root of this whole thing here is just going to leave you with h tan x. However, the square root of this whole thing here, I mean, there's no cancelling of any kind there, so the square root is just stuck there, you see. And then here on the left, you just have c d, you see, because remember, anything that has a square root symbol, if you're multiplying stuff in here, this is in brackets, is together, this is in brackets, together. The square root symbol goes with each of them individually. You see, it's just like exponential laws. With your exponential laws, you know that a dot b, if it's like squared, you know it's the same as a squared dot b squared. Same with third laws. If you have a third and you have like a and b, the third goes for the a, the third goes for the b. That's the analogy you have used here. And that's how you tackle this question, you see. Not crazy, not hard. We were literally just flowing, because that's what we do, man. We flow, you know. Flow like the water. Yeah, that was just said. Did I just say that? Yes, I did. I feel like I left out the question here, but it looks like this is the only question for 7. Like, I don't see a 7.2 or anything. I hope I didn't forget it. Because normally these kinds of questions, they always have like a follow-up question, like a 7.2 or whatever. But this is the only question that I see here. So, hey, it's okay. It's okay. We're not going to fight it. This is the only thing that we see. So, that's okay. Let us just move on to question number 8 now.
Question number what? We are busy with question number 8. So, question number 8. Let us see what they want us to do. Let's see. What does it say here? It says M is the center of the circle SVQR. Let's see. So there's S over here, V, Q, and R, and then they say it here SV and and QR. SV and QR are equal chords. Okay. So obviously, when you're going to be working on, Euclidean geometry questions, don't just read the questions, Like, obviously, it doesn't mean you have to also spend like 20 years just looking at the sketch and analyzing. No. The idea is just don't let simple things slip. Like here, you see, they have told you that you have a circle, and then they're telling you that these are equal, and then you see you have equal chords here. This chord is equal to that one. And then here they're telling us that PR is a tangent, and then QP is a tangent. So remember, tangents from the same point are equal to each other. And then also the angle between the tangent and the chord is 90. So this is 90 and this is 90. See, that will come in handy. This is just the radius of a circle. That may come in handy too. So let me make these 2 lines so that it doesn't show as though like they're all equal to each other. Anyways, all this being given, they said that RPQ is 70 degrees. So if this is 70 degrees, this can easily be found using, things like isosceles, triangle laws, and all that. So for 4 marks here, they want us to get R2. R2 is going to be super simple. It's kind of strange why they want us to get R2 for 4 marks, because I think here they just want to state some of the things that we know, but they don't know we know them. You see, like firstly here, you're going to state that PQ is equal to like RP. I'm like, hello, RP. So the reason is tangents from the same point. Tangents from the same point. So obviously you don't have to write the whole thing like tangents from the same points are equal, blah blah blah. You can just write tangents from the same point, because tangents from the same point, they basically have to be equal to each other, or they are equal to each other. Okay, so therefore we can say here, therefore RPQ is an isosceles triangle. RPQ, or we can say therefore, this is more of a conclusion from the statement we've just made right now. No, come on, bro. Okay, let's just say PQR then, or PRQ, since I wrote PR first and whatever. So therefore this is an isosceles triangle. You see, that's a conclusion. So here you can say now R2 is equal to 180 degrees minus 70 divided by 2. You see, so you've written this out. That's why you're able to write this statement here. And then here, obviously, this is just going to be 110 divided by 2. Now, 110 divided by 2, we all know that that is just going to give us 55. I mean, like, that's not even an issue, you know. That's not even an issue. So this is going to give us 55 degrees. 3 marks, huh? I think so. Q1 is the next thing that they want us to get here. So Q1, okay, normally what I can safely say is, if you get angles, put them on your sketch. You know, they'll come in handy. Just like now, Q1 is so simple. We just have to state that angle MQP is 90. So here, MQP, this is equal to 90 degrees. Our reason will be the radius is perpendicular to the tangent. You see? And then here we can then say, therefore, Q1 is equal to 90 minus that. You see? Therefore, Q1 is equal to 90 minus 55 degrees. You see? These kinds of questions, remember, they'll give you a mark for the statement and the reason for like the very first thing there, and then you just you know, write out the rest. That's why Euclidean geometry is actually not so bad, because you get so many marks for writing so little things. Like here, you see, get a mark for your statement, your reason, and then your conclusions here. Okay, we keep moving forward, because why not, right? Why not? Once they give you good stuff, you take them. M2 is what they want next. So obviously this is normal for your exams. You're going to get a Euclidean geometry question that has angles and stuff. Like now, they want what? M2. Sounds like the name of some highway. M2 is here. It doesn't look like it's going to take a long time to get M2, because remember we said whatever you get, write it out. So here we got 35 here. Automatically we know that this is equal to 35. And you may be thinking, why don't we get M2? Yeah, we could get M2. I mean, like, it could be useful. We just don't know. Wait, so obviously at this point in time, I'm thinking to myself, okay, fine, M2 is in an awkward spot. So how many marks are they offering? 3. That's not so bad. That's not so much. So yeah. Oh, wait, I'm already now thinking of things like exterior angle of a triangle. Because oh no, this is not a straight line. I thought it was a straight line. So I think without overthinking it, let me just do the first thing that I think is going to give us marks here, so that I don't spend like time on this, because wait, these two triangles here, they are basically similar, because you see, wait, are they similar? No, they are congruent, because this side is equal to this side is equal to that side, and then this side is equal to that side. Yeah, all these two are congruent. You see, V, S, M, and P, R, M, they are congruent. So we need to prove that, you see, because all the angles, all the sides are equal to each other. V, S, M over here. Let's talk about the triangle. So we said here triangle V, MS, or let's say in triangle VMS and triangle, the other one, let's call it PMR. In these two triangles, right? No, QMR. Is that a Q up there? In these two triangles, we'll basically want to show that they're congruent. So proving congruency just so that 3 things of the 2 triangles are equal, instead of without you proving that all 3 angles are equal. Yeah, just show 3 things are equal. Like it can be 2 sides and an angle, 2 angles and a side. It doesn't matter, as long as it's not like 3 sides. I mean, as long as it's not like 3 angles. 3 sides is okay, like here. So here we're going to state that VS is equal to QR. So let us do it. VS is equal to QR. This was given. Thank you. And then we're going to say that VM, MS, MR, and MQ, they are all equal because they are radar. You see, MV is equal to MS is equal to MQ is equal to MR. The reason is radii. They are all the radius of that circle over there. You see, and then therefore we can now say these are congruent. You see, therefore VMS, triangle VMS is congruent to triangle V. What you doing, bro? QMR. They are congruent, you see. So here we can then say, therefore, obviously this is 35 and this is 35. We can just get this angle. It's going to be equal to whatever M2 is. So here, therefore, we can just throw in a 35 over here, 35 over there. Yeah. 3 first, my guy. So here M2. But let's see what you could have also done. Yeah, no, it's fine. It's fine. Let's just say M2. It's a coincidence that M2 is equal to 70. So here we can then say that M2 is going to be equal to 180 minus 35 minus 35. Your reason here, you can literally just put interior angles of a triangle. Interior angles of a triangle. Nice. That's the way. I like it. Whew. Question 8.2 now. We are getting in the realm of, as a normal Euclidean geometry kind of questions. It says here TV and VU are tangents to the circle with center O at T. So they are tangents to the circle. Where's TV? TV is this one. VU is this one. You see all that information? It's like gold, man. Gold. It's funny how we have two questions where they're both having things like tangents from the same point. So obviously here, you want to spot where the radius is. You see, so this angle here, it's equal to 90. This angle here, it's equal to 90. Don't take that for granted. Okay? Don't if the universe gives you something, don't demela it, Don't be that guy. Take it and be grateful. So here we have a circle with center O, and then it says here at T and U respectively. Wow, okay, no. Oh no, these tangents TV and T and VU are tangent to the circle with center O at T and U respectively. So they mean here the tangent is touching the circle and there. Nice. And then it says here TSRUY. TSRUY, yes, are points on the circle. Layaga. No, where's Y? Oh, there's Y there. I went to V. So these are points on the circle such that RT is the diameter. Okay, so this is important. Wow, this is gonna be freaky, ne? So don't get confused here, because you wanna realize that R, U, and V, it's not a straight line. Don't forget, it's not a straight line. These two add up to 90, and then these three add up to 90. See, it's just a coincidence that they both add up to 90. This is not a straight line. You see, from V to U to R, it's not one line. So don't get confused, otherwise you're going to cry. So if this is the diameter, if they said RT is the diameter, it means that this is also equal to 90. It makes sense because, this shape has to be is a cyclic quad. And remember, cyclic quads are supplementary, meaning they add up to like 180 degrees. Then they say the X is the midpoint of the chord TU. Okay, so much information. So the idea with Euclidean geometry is, don't rush it. Where are you rushing to? Read your description nicely, put your stuff nicely, you'll have a good time. Here it then says T3 is equal to Y. Let me label this Y here nicely. T3 is equal to Y. Yes. Okay, I guess we're ready to rock and roll, man. I feel like this question is going to be quite interesting, Quite interesting. Euclidean geometry, I'm going to say something that most people will disagree with, but Euclidean geometry is actually a vibe, Like, this thing is a vibe, man. And I know I just probably made a few enemies right now. Like, what? This nigga? This bro is busy saying that, hey, this is a vibe, but this thing and I are not friends. No, I'm sorry, But because you're watching this, it means that you also want to be friends with Euclidean, because you can't just keep hating it and expect to pass it. I don't work like that, bro. You don't work like that, That's just weird. They want us to, with all this what we've done, they want us to prove that they want us to prove that RU is parallel to SY. Where's RU? RU and SY. They want us to prove that they're parallel. Well, this does not seem so bad. It's 5 more questions, honestly speaking, Always just look at them as like an opportunity to bank good marks, because 3-5 mark questions is like 10%. So every time you get a 5-mark question, try to get as many marks as you can there. So proving that lines are parallel, I mean, like, just think of fun. Okay, just think of laws of lines that are parallel to each other, you see. So you're gonna need to identify things like co-interior angles, alternating angles, and all that, you see. Just do what you can to prove that these are parallel. So what you do is, if you're going to prove that these are parallel, already be looking at them as though they are already parallel, because we just need to prove that they're parallel. So it's almost like they're telling us they're parallel. We should just look for the reasons why they are parallel. So on my side, I mean, my go-to for proving parallel lines is definitely fun. Gonna put here F U N. There we go. So you may be thinking to yourself, okay, what do you do when you're trying to prove that lines are parallel? Well, the one thing that I normally do is, well, this is a cyclic quad, so who knows, that can help us in some way. You'll never know. Well, yeah, I mean, like, because if it's a cyclic quad, you remember you want to look for things like where you have alternating angles. Let's see. So here you have this angle here. Technically, it's equal to that. So if there's a way you can prove that, then you will be good to go. Furthermore, yeah, I mean, like, this one here, if you can prove that it is equal to this tiny one. So to be honest, like, just looking at this sketch, it just looks too cluttered, you know. That's the thing with Euclidean geometry. Sometimes it feels like you're just dealing with so much, and it becomes a bit overwhelming. So we're gonna try and deal with it, you know. Gonna try and deal with it as best as we can. So yay. I feel like I should pause and actually think about it, and then I'll let you know how long I'd paused, because hey, you see, I'm about to sit here and just stare. But let's do it. You see, let me record me sitting and staring and getting dribbled. Who knows? Maybe you saw what we should do already, and it's nice for you. It's good. Oh wait, we have tangents. So I feel like I'm not using my own rules here. Hey, Dr. Cape Town, me. DRCPT. Let's use Dr. Cape Town. So we have a diameter here, so it gave us these two. Fine. But then we have radiuses here. Yeah, fine. That's okay. I mean, like, it's not a big deal, really. This is good to that. It's really not a big deal. And then we have, like, cyclic quads. So we should think of, like, exterior angles and all that. The only thing is we don't have any exterior angle to this cyclic quad over here, because no line is, like, straight going out. This cyclic quad over here, we do have exterior angles. We won't have this one. This one here is equal to this one over there. So this is equal to that one over there. That's all that we have. So I mean, if we can prove that these are supplemented, that would be good, but it doesn't look like it's happening easily, huh? P, we have to look for parallel lines. We don't have any. We're trying to prove them. But for T now, we need to think of tangents, though, you see. So let me clean this up a bit and start thinking of our tangents. So with our tangents, usually that's where things go down, you know, on the tangents and all that. So thinking of your tan chord theorem, we have to be careful here, because let's see. We're trying to prove parallel lines, so we're trying to use alternating angles and all that shandies. Let's see here, this, that, and that. This is not very fun to look at, but we gotta do what we gotta do, you know. So when push really does come to shove, like how it is now, we obviously, as I said, we need to think of the tan chord theorem. You see, use the tan chord theorem to help you. If you don't use the tan chord theorem, you are not going to have a good time, and we want to have a good time. So yeah, let's do what we can, you know, because if you don't do what you gotta do, you will cry. Okay, so the first thing that I am spotting here is, I mean, if you think of your laws, right? Your laws. Remember, we spoke about the radius of a circle. So if you look at this is the radius of a circle, and it is cutting the what you may call, it's cutting the chord in half. So clearly if this is cutting this chord in half, then it means that this angle here is a 90-degree angle. So that's, I think that's what we're going to play around with. I think that's where we're going to get our marks, because we know this is 90, né? We just need to show that this is 90 as well, and then we'll have like corresponding angles, because I mean, like, you know, why not? So I was busy focusing on alternating angles and co-interior angles, but I was forgetting there's like corresponding angles right over there. Hey, let's do that. So x1, we know that this is equal to 90 degrees. Our reason will be radius bisects chord in half at an angle of 90 degrees. So honestly, in my opinion, I'm writing all this because sometimes if the short one does not come to your head, just write out what you know. You see, radius bisects chord in half at an angle of 90 degrees. So that's going to give you 2 marks, you see. Now we just need to show them that we know that this is 90. So RUT, we're going to show them that's 90. RUT, this is equal to 90 degrees. This angle here, RUT, it's equal to 90 because angle subtended, angle in semicircle actually, angle in semicircle. Okay, good. And then what? Yeah, we've proven that that's 90 most. How? So yeah, this is equal to 90 and that one is also equal to 90. So this is like 4 marks. So here we can say therefore these are parallel because we have corresponding angles. So here therefore RU is parallel to SY. The reason is we have found corresponding angles that are equal, you see, because RUT is equal to X1, and the reason here is corresponding angles. So us writing corresponding angles, we're trying to prove that the lines are parallel because we are seeing corresponding angles. Wow, I can't believe it took long on this 5-mark question. I don't believe it. They want us to prove that T1 is half of Y. Where is T1 now? T1, they want us to prove that it is half of Y. Well, T1 is a point that is clearly, this is T1. You see, T1 is over there and then Y is over there. So the one thing you can do for yourself is find angles that are equal to Y. You see, it's that simple. So here it looks like we can use the 10 chord theorem. But the 10 chord theorem here, remember, this is how the 10 chord theorem works. You just want to look for a tangent and the chord, and then the angle opposite the chord. So here you have a tangent, and then here you have a chord. So the angle opposite this pink chord here is angle R2. You see, so this is Y because of the 10 chord theorem. You see, this triangle here is telling you have the 10 chord theorem happening, 10 chord theorem shandies. This is the tangent, this is the chord, and this is the angle opposite the chord. So that's your 10 chord theorem because this angle is at the circle. So we can start off by saying that, you see. What did we say here? R2. How? Where is it now? Oh, so far though. R2 is equal to Y, 10. Yay. Yo, bro, you can't even write nicely, man. Can't even write nicely, just a little bit. 10 chord theorem. Nice. Very nice. It's just a 10 chord theorem, yo. So you see, our focus is not even on T because where T1 is, there's nothing there, So try and get other stuff that's equal to like R2 now. So remember, we have alternating angles here. So this is equal to that. We have, O1 is equal to Y because alternating angles. O1 is equal to Y, alternating angles, because you've proven that those are parallel. So if it's proven, you can use it. And then you see more geometry. You have to know your laws of triangles, because what we're seeing here is that O1 is equal to T1 and S1, because of an exterior angle of a triangle. So O1, first we can state that T1 is equal to S1 because, you know, opposite angles of an isosceles triangle. Angles of an isosceles triangle. So here, S1 is equal to T1 angles of an isosceles triangle. You see, yeah. So using that as a reason, it's really nothing crazy. It's really quite simple. There we go. If you feel like you need to put TO is equal to SO first before you say that these are equal, I mean, like, be my guest. But it's really not a big deal, to be honest. But hey, me, I don't want to get shouted at. But no, why would somebody shout at me? This is 100% okay. You're saying that those two are equal because you're seeing that they are angles inside an isosceles triangle. So, I mean, like, it won't really hurt to put O2. Let's just put it before here. O2, I mean, OT is equal to OS. The reason is red eye. Can just squeeze it in there. Do that, red eye. And then we wrote the whole isosceles triangle shandies over there. What you got next? What you got next? Yeah, so now we can say, therefore, we know that O1 is equal to these two put together. We know that O1, where is it now? Well, oops. O1 is equal to, no, where am I? Yeah, I'm here. O1, where did I write that whole isosceles triangle thing? Me. Getting lost here. Busy putting things in the wrong place. My guy, are you okay? Is everything okay? Or you're tired? Yeah. What am I saying? What am I even saying? Anyways, let me remove this and we can carry on nicely. So here we said O1 is equal to 2T1. Or rather, let's say O1 is equal to T1 plus S1. The reason is exterior angle of a triangle. You see, remember, an exterior angle of a triangle is equal to the sum of the opposite interior angles. Like this one here is equal to these two combined. You see, you need to know your triangle, or just know your geometry laws. You'll be fine. You see, this is equal to these two combined. So because they are both equal to each other, I mean, we can then say here, therefore, O1 is equal to double whatever T1 is, because this plus this gives you 2 of T1. And then you can then say, therefore, y is equal to 2 of T1. And then here you can then say, divide by 2 on both sides. You're going to have 1 over 2y here. And then T1. Very easy. Thank goodness I have a whole page for just that. Like, wow. Anyways, that's that. We're about to go to question number 9 now. Use the amount of times these papers ask for this proof. Yo, it's so many, eh? So obviously, yeah, this is one of the proofs you definitely need to know how to work out. Yeah, it's quite simple. There's a tutorial on it as well on the main channel. It's just like, this is such like a common proof. So just make sure you at least know it. The idea here is they said in the diagram points D, E lie on AB. Yes. There's AB here. D is there. There's AC here. E is there. Yeah, respectively, such that this DE is parallel to BC. That's good. And then they said here DC and BE are joined. Let's see. DC and B are joined. Yeah, so these are important, these dotted lines here. If they were not there, we would need to put them on our own for these proofs. Here they say use the diagram to prove the theorem that states that AD, so it's like this here, over BD is equal to AE over EC. So that's what they want us to prove. So let's remove that so that we don't have like too much clutter on our diagram, because in our diagram we're going to use it. Anyways, let's see. Got to get another color. So in terms of you proving what they've just said, you know, it's almost like routine work, this proof. You need to make two constructions. You see, the first construction is you need to construct a perpendicular height for the triangle ABE. You need to construct one perpendicular height that way, and then you need to construct another one that way, because either one of the two will always help you to work out the area if you use half base times height. But anyways, let's see. We're gonna say construct H, which is gonna be perpendicular to AE. I'm going to color code it as well. Whoa, I gave myself so little space. Me. What is wrong with me? Hey, let's draw AH. Let's draw H perpendicular to this thing. Yo, my guy, you're not even trying to make it perpendicular. There, I tried. Okay, that's H. The next thing you're going to draw is, you can call it K, you know. So the other one is going to be K. It's going to be perpendicular to, let me just remove this here. Do that, do that, do that, do that, do that, do that, do that. Thank you. So this one you're gonna label it K, and then the pink one you're going to label it H. This should at least give you a mark, you know. So you've constructed this, and then you also need to construct K. So let's say here construct K perpendicular to what? To AD. That's the way. I like it. Whew. Okay, fantastic. So once you've done that, all you need to focus on is the fact that when you're thinking of the orange line works with this triangle over here, because this triangle over here, its perpendicular height is K, and then its base is BD. You see, this is your base, and then K is the perpendicular height. And then for the pink one, same idea. You're going to work with the what you gonna work with, me bro? You're gonna work with for the pink one, you're going to work with this triangle over here. Yay, bro. Hey, you can draw a straighter line than that, Joe. Like, come on, man, come on, pull your weight. Much better, much better. Let's see this one here. So nice. Ooh, nice. So with this triangle, obviously this is the perpendicular height. So a deeper explanation on all these, you know, it's like they're on the main channel. You can always hit me up if you want it. But obviously on YouTube it's there, like legit. What am I going? Go back. It's definitely there. Whew, where do we start? Well, since we want AD and BD, we're going to start with the orange ones first. So starting with the orange ones, we need to write down the area of triangle ADC. So area of triangle ADC. So let's put here area of triangle ADE. The area of triangle ADE is a half. The base is K, and the the base is AD, bro. The base is like AD. Yes, we can see that. And the perpendicular height is like K. You see, that's the area of ADE. If you write that area over the area of triangle BDE, so area of triangle BDE, this here is equal to a half. The base, we know that it's just BD over there. The perpendicular height is a K, because remember, with a triangle, your perpendicular height, as long as you have a line going up there somewhere, this will be the highest point of the triangle, right? Your perpendicular height can be this distance there. You see, that's what's happening with something like BDE. You see this triangle here, this is the base, there's the perpendicular height, you know, because it's parallel to the base. I mean, it's perpendicular to the base there. So this is the area of this triangle over the area of this triangle. So this is an expression. We know that this will cancel this will cancel that, and then we're just left with AD over BD. So this is at least half of your marks, one way or the other, because that's the left expression. And then we do the same for the pink, like legit. We literally just repeat for the pink. So let me even use a smaller, you know, point there, so that we don't waste space. So here we can say area again. Here you're going to use the same triangle again, you see. But then yeah, literally area of triangle ADE. Let's say here area triangle ADE. If you put that over the area of triangle, the pink one here, so let's call this one, you can call it whatever you want really, DEC. That is actually going to be, so this area now for this big triangle, now if you're going to look at the pink as the perpendicular height, the area here needs to be like a half, the base is like AE, and then the perpendicular height is like H. And then for the blue, I mean the pink, bro, the pink, same thing, it's a half, the base is like EC, and then the perpendicular height is like H. If you want hints, just be looking at these, you see, like legit, the proof is all the hints that you'll need. So here, this cancels this cancels this, and obviously this is where the fun part comes in, because all the heavy lifting has legit been done. If you've done all this heavy lifting, it's time to celebrate, because at least this is like 80% of your marks. The last statement is literally you writing something that you know about what you call areas of triangles, and you know, having parallel lines, yada 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 yada. So the idea is you need to keep in mind that the areas of triangle what? The areas of triangle DEC and this area here, DEC and BDE, they are equal because it's areas of triangles between parallel lines. So here, let's state that these are equal to each other. This one, gonna state that this area here, let's copy that. I just wrote this up here and this. Let me actually swap them around because I ran out of space. So let me actually just swap these around so that it doesn't look weird, you know, doesn't look weird and awkward. So let me put my constructions up there, because I feel like that. When I go up there, go up there. Why do you want to stay down here? Go up there. There you go. See, it's not scary up there. Anyways, so here we need to state what we know about the area here and the area there. So we're going to state that they're equal, and the reason is going to be areas between parallel lines, areas of triangles between parallel lines. So what you got next? So it's like it's like area of triangle BDE is equal to the area of triangle area of triangle triangle what? DEC. The reason is areas no, come on, write nicely. Areas of triangles between parallel lines is weird, right? Between parallel lines, I don't know if it's parallel, but I'm assuming 2 R's, 1 L. No, angazmi parallel lines. So here you can then say therefore. So because you see, I mean, here you've used the same. It's still ADE here. It's still ADE. So as long as the bottoms are equal, the bottoms, then you know you're done. Because I mean, like, as long as you've stated this, then you can then say therefore AD over BD, because you know this has been simplified to that, this has been simplified to that. You see, because our task was to just show that, well, we could have even started by saying this is equal to that. We could have started that way, and then at the end we can just say this is equal to this, because I mean this is for the same, this is coming from the same triangle as this one over there, you see. So it's good. Let us move on to the next question. Question number 9.1. Would you look at that? 9.1 looks like, hey, yeah, this question, but don't be scared, don't be scared, because you know these Euclidean geometry questions, they're like bullies, you know, like they're just like that, they're just so annoying, but it's okay. Let's see what you can do. It says in the diagram ABCD is a parallelogram. Thank you for giving us a parallelogram, because if you have a parallelogram, you have so much information, you know. This is equal to that, this is equal to that. Here it says the diagonals of ABCD intersect at M. Thank you. F is what? Is a point on AD such that AF, and the ratio is, where is AD? Where is F? You see, I'm busy reading, not looking. They said F is a point on AD, yes, such that the ratio between AF and FD is 4:3. So this is 4:3. Yeah, that kind of information, don't take it for granted. It's quite important. It's giving you so many things without saying much. Don't take it for granted. The next thing here is saying that E is a point on AM. Where is AM? Where is E? What are they talking about, these people? E is a point on AM. Let me see. So E, where is E? Is a point on AM. Yes, such that EF. Okay, yeah, these are parallel to each other. So with cases like these, now always spot, you know, the proportionality theorem, triangle stuff, for you to work out all these easy things here. Let's look at them as easy, otherwise it's not good. So here it says FC, and where's FC? FC and MD intersected G. Yeah, so sometimes these questions, it seems like you're just given too many things, eh? But it's okay. For 3 marks, they just said we should get the ratio with reasons. We should get the ratio of EM over AM. That one is at least quite easy, because we know that AF, right? Well, technically speaking, FD, right, over AD is equal to EM over AM, you see? Because proportionality of proportionality of similar triangles, you know. But apart from that, the easiest way to put it is, you want to say that the reason for that ratio is line parallel to one side of a triangle. So let's what you gonna do? Yeah, let's keep it simple. Let's really just keep it simple, like real simple. And how are we gonna do that? Yeah, we're just gonna show that this other side also, the ratio is like 4:3 here. We just need to show that. So to do that, we're going to say that what do? Do you want to write AF first? Do you want to write FD first? It really doesn't matter, you know, it really doesn't matter, but let's just write AF first. So here we can write the AF is AF over what? Over FM. This is equal to AE. I don't need to be thin anymore, please. Thank you. There's AE here over EM. This is equal to technically 4/3. The reason is line parallel to line parallel to one side of triangle. To one side of triangle. Yep, that is what you do for these kinds of questions. It's not bad. It is just how it is. So we have stated what AF over that one is, you see. So yeah, line parallel to one side of triangle. So because we have stated that, right, we can basically write the ratio that we want, like here, EM over AM, because here we can then say therefore EM over AM. We know that EM is just a 3, AM is the 4, and the 3, which is just a 7. Easy marks, easy right, easy left, steady right, hard right. If you don't play games, then what I just said right now made no sense to you. But if you do, if you're like a, you know, yeah, never mind. let's not do that to other people. 3 marks. It says CM and ME. We need to get the ratio between CM and ME. Where's CM? CM and ME. This one is not going to be so bad because I mean, like, this is already a 3. We don't have anything for this. We don't have anything for that. We don't have anything for that. So what you do is you need to use information from, from other sketches, other triangles that have information. Use those to help you to get information in this sketch. Because if you're looking at this here, this is what we could use for what they want us to like work out and all that. So yeah, so for cases like these, right, usually my go-to for questions like these is I always try and spot things like, which lines do I have that are parallel? Like we can see there's the yellow ones over there, and yeah, there's just so much going on. There's just so much going on. But then this is where also things like your laws of normal parallelograms really bail you out, because if you're forgetting that this is a parallelogram, then this question, it's like game over. So that's why you need to, like, you see, even in the beginning, I think it would have helped if we stated that this entire line here is equal to this entire line, because you see, it's what? Those are diagonals of a parallelogram. So already you know that this is just a 7. You see, so you know that this over this is just 3 over 7. So they want us to get what? They want us to get CM and ME. Let's see, CM. Yeah, CM and ME. Yeah, that one is going to be quite easy, because we just need to show them that MC is equal to AM. So here, CM is equal to AM, which is equal to 7. Let's say here, diagonals of a parallelogram. Oh, this parallelogram can tell us what parallel is. Okay, it has one R. Parallelogram. Fantastic. This is good. So let me just write this better. CM and AM. So there's AM over here, CM over there. Good. So now we can easily just write out our ratio now. CM over EM is just 7 over 3. See, CM here, CM over ME is equal to 7 over 3. So cases like these, they show you that, the description is where you need to go if you get super stuck. Because us forgetting that this is a parallelogram, A would have been in big trouble. Like, so much trouble. It would have been so bad. And like, damn, The next question wants us to get the ratio of these areas. So getting the ratios of these areas, I mean, use what we've used here. You see, don't forget what we have done in this theorem proving what thing. So always try and use that as like a hint. Let's see, how many questions does this thing have? 10. Yeah, but we're almost there. So here, let's see, where is triangle FDC now? Triangle FD and C. Okay, I feel like I want a fresh sketch, but yeah, fresh sketch. My foot in the exam is what they'll tell you. So we have FDC here. Let's see what it is. Let's just draw it out. Yo. Let's make it smaller so that we don't have to draw so far. Okay, yeah. Oh, yeah. Doesn't want. Let's finesse it quickly. Yes. Oops, nope. Let's see this. Yes. Yeah. Oof. Yeah, it looks so bad, But it's better than nothing, Hey, but that phrase though. Hey, that phrase. It's just so snacks. But let's see here. I'm busy supposed to be drawing a triangle. I'm busy talking about phrases and them being snacks. Hey, do one thing, man. One thing at a time. So this is the one triangle, FDC. The other one is BDC. Let's see BDC. Where's BDC? Probably gonna get a new color for it. Where's BDC? BDC, where are you? BDC. Yo, okay. You're now okay. So you have that line over there. You have this line over there. How? Why is this not connected? Oh, no. Don't take them both. Just take one of them. The other one still wants to leave. The other one is finished leaving. You can take him. See, there we go. Okay, these are the two triangles they're talking about. The one thing you can remember about these two triangles, is that there are triangles in between parallel lines, so they have the same base, so don't forget that they have the same base. Wait, what am I saying? Yeah, they have the same base, so don't take that for granted. Now let's see here. If you're going to use these two triangles, firstly, what you can do for yourself, let's see here, what do you have? You have B, let's see here. So we say we're dealing with triangle BDC. Yeah, BDC, BDC, BDC. And what else are we dealing with? We are dealing with yeah, this is, I think, one of those where we really have to think outside the box, because I think obviously for me in an exam, I don't wanna lie, these are the kinds of questions I leave for last, because I mean, like, what's the point? There's really no point in finding yourself struggling if you know that you have not like finished your paper and all that, because if you haven't finished, then you're usually going to have a hard time, so don't put yourself in a situation where you end up struggling just because you feel like, I don't know, you can do it. Yeah, obviously it's good to be positive, but the idea is, what I'm trying to say is, yeah, don't waste your time, okay? Don't waste your time. So with this kind of a question, you really do have to think outside the box. So thinking outside the box, this is what you need to look at. With this rectangle, right, this is, again, I think this is like, a good level 6 kind of question, in my opinion. Yeah, so if you look at this triangle here, right, this one over here, this triangle here, let's do this as well. And yo, it's too much, my guy, too much, my bro. And this one over here, yo, no, yo, Wednesday Johnny. So if you look at these two triangles, the pink one, the yellow one and the red one, the yellow triangle and the red triangle, those are obviously going to be equal to each other. They are going to be equal to each other because there are two triangles in, well, logically speaking, if it's a parallelogram and you cut it in half, the one area is going to be equal to the other area, you see. And these are two areas of a triangle between parallel lines, you see. So yeah, so these are equal because of diagonals of a parallelogram. So that's the first thing we can state for what we're going to do. So let me actually take a screenshot of this thing here so that I don't keep going back and forth. Like, why I gotta do that? Come on, man, come on, just do this. Don't want to keep coming back up here. Like, no, we want to stay down there. Oh, that sounds a bit weird, but ish. Yeah, ne? We want to stay down here, please. Let's bring our sketch up here and let's do what we gotta do. Do what we gotta do. So the idea is, we said that the first thing is, let's state that the yellow and the red are equal. You'll see why just now. The reason we're stating that they're equal is because we eventually want to write down two expressions of areas where we can have the ratio of this blue to the yellow and this blue to the red. If we can do that, we'll be good to go. We'll be good to go, because what we basically want is these numbers in here. We want these values in here, right, inside this sketch over here. That's basically all we're trying to do. We just want these numbers here inside this sketch. But like, we could just have said AD is equal to this. Yeah, like, in my head, I'm like, bro, what else if out are you doing? But let's just carry on. Just, there's method to the madness. So here we're gonna say that area of triangle, we can do the yellow one first, right? The yellow one is gonna be like BDC. Come on now, BDC is equal to the area of triangle, the red one we can call it triangle ABD. They're equal. The reason is our diagonals of a parallelogram. Diagonals of a parallelogram. Whew, is hot, guys. It is so hot. No, it's not like, okay, it is physically hot at this very moment in time, but ish, this question though, these are the kinds of questions, as you can see, there's no point in doing them until you're like 100% done. So we know that this triangle here is equal to that one. So what we can do is we can write the ratio between the blue one and the red, and then a ratio between the blue one and the yellow. So here we can then say, therefore, the area of the blue one, therefore the area of the triangle, that the small one here, FDC, if you put this area right over the area of triangle, let's see here, triangle BDC, this is going to be equal to the area of that same triangle over the area. Oh, I forgot to put the triangle symbol. You forgot the triangle symbol. Why you forget the triangle symbol? Excuse me, I'm not trying to do something about it. I just like the accent. It's amazing. Actually, never mind. Yeah, like let's lost, because sometimes if someone is like looking at this in the AMs and like super tired and you're busy making jokes, it's like, dude, get to the point. Like, get to the down point. So down here we have A, B, D, and so obviously the areas of these two triangles, you have to be careful now. Because what we want to do is we are trying to show that the what are you trying to show, bro? Like, what are you trying to show? So we're trying to show basically that the triangle FBD has the same height as the triangle triangle ABD. Let me put it this way, because let me put it this way. If you look at this triangle over here, if you look at it nicely, right, this is your perpendicular height from here going downwards. This is your perpendicular height, you see. For the blue one, if you look nicely, from here going downwards, this is also your perpendicular height, you see. There you go. It's your perpendicular height, because you see it's a line going straight down towards the base at an angle of 90 degrees. Line going straight down towards the base at an angle of 90 degrees. So what you want is, you want to use this portion of your expression to help you end up with the ratio for this. You see, because the ratio of this that they have asked for, you have proven that it is equal to this ratio over here. So now you can just work with this ratio. The area of the triangle at the top, we know that the area of our triangle at the top here, we can just say a half. The base of our triangle here is just FD, you see, a half the base, and then the perpendicular height, you can label it H. This will also just be H. Let's label it H. This is equal to a half. The area ABD, you see, ABD, the base is AD, and then the perpendicular height is just H, you see. There you go. And then this, you know that the half and the what, they just cancel each other out, because why not? You see, this cancels that, this cancels that. Now you have FD over AD. You see, they want the ratio of this, because that's what they said in the beginning. You see, in the beginning, they just want you to calculate, giving reasons, these ratios. So for this area, this is the ratio they want you to end up with. And luckily, FD, where is FD? FD is a 3, AD is a 7. So here, FD is a 3, AD is a 7. And then we're good. Like, oh, that is so good. We are almost done. We're almost done, because we're moving on to the next and last question. So this question was okay. It really was okay. I think the part of using the perpendicular height here and the perpendicular height here, yeah, I think that's some creativity. Like, damn, man. Damn. Like, oh my gosh. Like, oh my goodness. Anyways, it is what it is. Let's just move on. So we are at the last question. On this last question, we can clearly see, we're given a weird sketch, eh? Yeah. This one you kind of need to analyze what we can, but not too much. Otherwise, we're just gonna go in circles here. It says 2 circles, haha, pun intended. I literally did not intend on doing that. It says two circles with center A and B intersect at X and Y. So they cut each other over there and they cut each other over there. And then they said the radius of circle A the radius of circle A is R. Where's circle A? What? These people, what are you saying? The radius of circle A is R. Okay, fine. They say that this is R, so this is R. Why are they being so extra though? And then it says, and the radius of circle B is small r. Oh, radius. Oh, big R, small r. Very lack of creativity. Very lack of creativity. What? Very lack of English. Okay, no, that was not funny. But anyways, here it says CX. Where is CX? CX is a tangent to the small circle. So this is CX over there. It's a tangent to the small circle. So if this is the radius, it means that this angle here is got to 90 degrees. And then it says here, yeah, it's a tangent at X, and it says DX. Where's DX? DX is a tangent to the big circle. Wow, this is some freaky stuff. I think they're doing it. I think we had another question where the 90-degree angle part. Wait, this is actually kind of weird. How can this be 90? And then this is a tangent to this. Oh, okay, no. The line does not go to the center of this big circle. So here for the big circle, we should just be thinking of like the 10 chord theorem, because this is the tangent and this is the chord in the circle, the big circle. So that chord, the angle opposite it, that's where the 10 chord theorem comes into play. So this angle x2, we already know it's equal to c2 because of the 10 chord theorem. Don't forget the 10 chord theorem. The 10 chord theorem is too underrated and sometimes a bit overrated, but mainly usually underrated. But how can you be both, bro? Pick one. Okay, I pick being underrated. It's too underrated. Here it says dx is a tangent to the circle at x. Fine. We really don't want to overanalyze this kind of a sketch because, you will cry. 5 marks, they said here. Prove that x, y, c. Where's x, y, c? X. Where's y? Y and c. Yes, this triangle over here. We should prove that it is similar. This is similarity. We should prove that it is similar to dyx. Where's dyx? dyx. Oh well, that's not too bad. I mean, like we already saw one pair of angles that are equal, because of the tan chord theorem. We love the tan chord theorem. We love it so much. Oopsie, yammer. Anyways, let's state what we know. X2, or rather big X2, X2 is equal to C2. No, yeah, we're proving similarity, so we're talking about these two triangles. I'm like, we already know. And remember, the rule of thumb is just prove that this X is equal to this portion of D, just like what we whoa, what triangle am I using? Yeah, this portion of X is going to be equal to this portion of D. This portion of Y is going to be equal to this portion of Y. Wow, that's very rare. And then this portion of C is going to be equal to this portion of X, which is what we have seen just now, you see. So we've just done the block one. This C, we've said it's equal to that X because of the 10 chord theorem. This is equal to that. So we said try and use these to guide you, because I mean, like this C, which is this one over here. Let me put it in red, color coded. Come on now, hey. This C here, we've proven that it is equal to this X over there. So this is telling us that the Y for the one triangle is equal to the Y of the other one. So if we can in some way prove that this is equal to this, will be good. But it doesn't look like that one is easy. So I would forget about the Y here. Hey, you never know. We'll see. And then technically, if those ones are equal, then it means that you can also prove that this is equal to that. I feel like the D1 and this one, these are a bit more promising, just because of things like the 10 chord theorem. Yes, the 10 chord theorem, because of the 10 chord theorem, this x1 here is equal to this d1. You see, because there's a tangent and a chord, and then this is the angle opposite the chord. Yep, 10 chord theorem has saved us once again. Oof, this feels good. Oh, we didn't give a reason for this. Oopsie. Forgot to give credit to the 10 chord theorem. 10 chord theorem. Chord theorem. And then what else? We also need what else do we need, bro? Oh, we said x1 is equal to d1. 10 chord theorem as well. X1 is equal to d1. The reason is 10 chord theorem. I feel like this proof is actually quite easy. 10 chord theorem. And then lastly, these and this being equal, you can literally say they're equal to each other because of interior angles of a triangle. Because anytime you've proven that at least two pairs are equal, the third ones, you can just use the law of interior angles of a triangle and say they're equal because of that. So here we can say CYX is equal to DYX is equal to DYX. The reason is interior angles of a triangle. Interior angles of a triangle. Because if two pairs are equal, the third ones automatically have to be equal to each other as well. So here we've proven similarity. Here you can then say, therefore, triangle XYC is similar to triangle DYX. DYX, the reason is angle. You've proven that all three angles are equal to each other. So that is fantastic, man. Well done. Yeah, for this question, clearly I did not finish because they want us to then prove this expression or deduce this expression. So we have proven that those two are similar to each other. I mean, like, that's mainly the heavy lifting. If you have done that, the rest is not going to be an issue at all. You just need to like brace yourself. So having to proven this, you just need to write out your proportionality expressions and all that. So you can write something like xy over dy. This is a y, by the way. So here let's say xy over dy. This, you know, it's equal to cy over yx, which is also equal to like xc over dx. xc over dx. Whew, okay. There we go. So this being done, what can happen next? Oh yeah, now you just want to pick two of them that can give you this, and likely you have xy here and another xy there. So it looks like these two will help you, but having to have written this, your reason, you will need to state that you're working with the proportionality of similar triangles. You see, that's what you can put down there, proportionality of similar triangles. If you left it blank, trust me, it's actually okay, but hey, let's just put it because it's more like a conclusion here. Proportionality of similar triangles. You see, so here from saying that, we can just work with those two first, specifically just these two. So let's actually just copy it, copy, and then paste, please. Paste, make it much smaller. So with what we have just written out here, we know that here you can just cross multiply this times that. Here you know that this times this gives you xy squared, because you're just cross multiplying, and then this times this gives you dy times yc, like that, you see, and then you will be done. Nothing crazy, nothing major. Let us keep it moving. Whew. Second last, they want us to prove that a1 is equal to b1. a1 is here, b1 is there. Hey, that actually looks quite easy, because here, let's use this. We know that b1 is let's use a chain. You see, this is equal to this, and then this is half of whatever this is. Same scenario here. This is half of what this is because of angle at the center of a circle is half the angle at the circumference. So let's start with that. You see, B1 here is equal to double whatever D1 is. So let's do that. B1 is equal to double whatever D1 is. The reason is angle at center of circle. You see, so we're gonna trace B1 all the way to A1. You know, it's like tracing it. So now we know that this is equal to double that one. So this angle here is just 2, whatever this is, half is just half of B1. You see, so yeah, that's what we know now. You see, D1 is just half of B1 because here you can just divide by 2 on both sides. So you know that D1 is half of B1. Now we can say that we know that D1 is equal to X1. That was proven. So let's write it out. D1 is equal to X1. That was proven. You see, this was a conclusion from this statement. So this here is another statement. We already proved what we are writing here. D1 is equal to X1. We proved it. So here we can then say, therefore, half of B1 is equal to X1. You see, because you're just tracing it. You see, this is equal to this. Now you're saying this is equal to that. So this is equal to that because they are both equal to D1. You see, now you know that where X1 is, you can put half B1 there. You see, half B1. Now you know that X1 is equal to half of whatever A1 is because of angle at the center of a circle. A1 is equal to double whatever X1 is. The reason is angle at center of circle. And then where X1 is, we know we can throw half of B1 over there. So here we can say, therefore, A1 is equal to 2. Where X1 is, we can throw half of B1 over there. And then just do a calculation, you see. This is equal to B1. This is equal to A1. We just traced it, you know. Just trace it. Take the point from one side and take it to the other side. If you had done it the other way around, it's 100% fine. You could have started with A1. Say that A1 is double whatever this is. And then here you write that this is like half A1. And then from there you say that this is equal to this because of the 10, because of like you've proved it. And then you would have been able to then say that this is gonna be half of whatever that is, blah blah blah. You'll still end up with the same idea if you had started on the left side. And now for the last question. Oh wow, this feels so good, dude. Yo. So here they're asking us to prove. Okay, they said if, you see. So if they start a statement with the if, it means that they are giving you that information. You don't have to prove it, whatever. It's like they're just giving you that information. So you should just use it, you see. Us using this information, we have to be careful. Okay. Oh, finally the last question. This feels so good. Ooh, let's see, is this clickable? Nope, not yet. But it's a PDF file, it is. But anyways, is it really? Well, I guess we'll never know. But anyways, I've been saying anyways, bro. Just get into it already, my guy. This is a 5-mark question. They said if anything that starts with the if, it means that they've already given you that. They're like giving you that information. So don't fight it, don't prove it, just use it. They said triangle CAY is similar to triangle YBX. Yeah, they are similar. They said here, if these are similar, then this is equal to that. Well, I think they want us to prove. What do they want us to do, Vele? Like, I feel like these guys, I feel like they left out something in this question. But I think from them having to have given us what they've given us, I think they want us to prove this expression, you see. So I think they should have said here, if this is similar to this, then prove that how do you spell that, my guy? You are misspelling that. Ish. Pun intended. Yeah, prove that this is equal to that. Yeah, prove this expression. Oh well, to be honest, if you have been given that lines are, if two triangles are similar, they told you. So you can just write out your proportionality expressions. You see, so let's write here CA over YB. This is equal to like AY over BX. And then all this is equal to like CY over YX. Whew, okay. So the reason for writing all this is just proportionality of similar triangles, like we mentioned, you see. Proportionality of similar triangles. That is what we are dealing with here. So let's put here prop of same triangles. So because this is the proportionality of similar triangles, we want to look for, okay, we're done this one for this last one. We want to go to our, what do you want to do? Huh? You want to go where? Where do you want to go? I want to go back here. So we're looking for something that is dy and something that is cy. Okay, there's something that is cy over here, but then there's nothing that is dy. So let's go back to our sketch and see what we can do about dy. Where's dy? Dy is this line over here. Okay. Yeah, I feel like dy is gonna be a problem, hey? But why though? Why is dy gonna be a problem? Is dy equal to anything? Nope, but let's see. Let's see here. We have to be careful because, hey, these kinds of questions, hey, they can hurt you so bad. But the lucky thing is it will be the last one, so obviously also only attempt these hardish questions when you know that you are like 100% okay. So wait, what we need to keep also in mind is that let's forget about dy for now. Where's what? Wait, this is yxb. Did we have any triangle that we proved something with like yxb? Nope. Hey, it's fine. But what we need to take note of is the fact that R is CA. So when we see CA, we know that this is good enough for us. And then, yeah, what is R equal to? It's also equal to AY. Where is AY? Is the AY anywhere here? So this is, okay, let's do it like this. This is, looking at what we have now, this is R, so it's like R over there. This is also R, so it's like R over there. What else do we have? R1, I mean the small r and the other small r. It's like BD and like XB. Where is BD and XB? So we have BD. No, there's just XB. There's no BD anywhere here. So let's change it to something like this and see what we can salvage. There's like YX over here. YX. What a wow. We want to end up with like R squared at the top. Yo. Yeah, the poppy is dancing. The doll is dancing now. The doll is busy there. Let's see what, my guy. Well, because the last question, I think my brain is like, so fried. My brain is like so fried. But we're gonna need to figure it out, and then we can just, close things off. So, what to do next? Yeah, so obviously when push does come to shove, the dy part, clearly that's the issue. We don't have an expression for dy's. Like dy is just a random line somewhere. It seems to be causing trouble. So what would I do? What would me do in the exam? Panic? Oh, no, I wouldn't panic. I would go back and sweep up all the other marks I can get, and then only come back here like way later, like way later, when things are good. So what you do is don't focus on what you don't have. You see, forget what you don't have. You'll worry about it later. Just try and write what you can that's like logically sound and stuff. So here, this is what we can do. This is the best bet that we have, you see, with the information that we have. So let's just take that expression and use it. So this expression, I mean, there's something squared and something squared there. So let's do that. R over small r, we know that this is equal to cy over yx. Where is yx? Yx is, let's check what yx is. I think that's where our dy is going to come from. Yx is this long line here, and then dy is a part of it. Okay. So obviously, because these are squared, you may want to square both sides, because I mean, why not? You know, we're trying to introduce the squares into the expression. So here you can square this. If you do it on one side, you can do it on the other side as well. But then you may be thinking to yourself, but then is that logically sound? Yes, it's like square rooting one side and doing it on the other side. So squaring both sides is okay. This is going to give you r squared over r squared. And then this is like cy squared over xy squared. So here you have to be creative. You have to think of all your other questions. Like here, you see, this is like this is like xy squared. And look, this is where the dy is going to come from. You see, because there's like dy and like yc there in like 10.1. So dy and yc, we can drop them at the bottom. So here we can say this whole thing here is equal to dy times yc. So one of them is going to cancel one at the bottom there. Is it really going to happen like that? Yes, it is, my guy. Yes, it is. So this is just r squared. So 1 cancels 1 there. And then here you just have one of them at the top. And then you have dy at the bottom. Oh, wow. Oh, it's not done. Okay, but here likely you can just flip it over. Because anytime you have a fraction and another fraction, trust me, you can just flip them both and then your answer will still be correct. So here, you can just flip them both. It's not something that you need a reason for. It's just logic. You see, if this is flipped over, the effect of you flipping it over is the same as what? Am I about to lie right now? No, it's the same as like, yeah, let's just flip it over. Because this is just that, you flip it over, and then this, you just flip it over. Because they are both fractions. You see, the ratio of this flipped over is the same as the ratio of that flipped over. Whew, Zion, if this was helpful, I mean, come on, give this video a like, man. Come on, man. Don't be that guy. Don't be that guy. But anyways, if you need assistance, trust me, these courses are gonna blow your mind. You know, they're gonna give you the marks that you need. Obviously, if you need something, you can always hit me up. If you have questions, you can always just try them out first, you know, and then when you're like really stuck, just hit me up with what you would have done and stuff, and then we can definitely work some out, you know. We can definitely work some out. But anywho, that is that from my side. Thank you for watching. I will catch you in the next video. Don't forget to like, subscribe, and share this with your friends. Oh, how does the Boys That Say videos end again? It's like I forgot. Anyways, it's all good. Ciao.